Hello friends, in this session we will look at knockout based tournaments. The caselet is in front of you. You should go through the case. The case goes like this. The BNP Paribas Open is a 7-round tennis tournament played on a knockout basis. That is, in each round, in a match between two players, the winner advances to the next round while the loser gets eliminated, with no match ending in a tie. Players can also advance if given a bye, which happens only in the first round. The players taking part are seeded 1, 2, 3 till the last player. In the first round, the top 8 seeded are given a bye, while the second player seeded 9 plays the last seeded player, and so on and so forth. In the next round, player 1 will play with the winner of the match 64. The player seeded 2 plays the winner of the match 63, and so on. These are designated matches 1, 2, and so on. And so on and so forth. This match will continue. The process continues in the successive rounds till a player emerges as the winner. A match between two players is said to result in an upset when a lower seeded player beats a higher seeded player. Question 1. What is the total number of players taking part in the tournament? The first question that we need to understand is, let's first broadly understand how this tournament is being played. This is actually a slightly complicated set, but given the importance of this kind of questions, it is really worth the effort to understand what is going on here and how to solve this kind of sets. So let us say if I am looking at a knockout tournament, in the final round, players seeded 1 and 2, they will be playing with each other. I am assuming that there are absolutely no upsets. We will come to the upsets in a little while. In the second round, I am counting from the last round. This was the final, this is the semi-final. In the semi-final, 1 and 4 will have played, 2 and 3 will have played. In the next round, 1, 8, 4, 5, 2, 7, 3, 6, they will have played. In the round before this, it will be 1, 16, 8, 9, 4 and 13, 5 and 12, 2, 15, 7, 10, 3, 14 and 6, 11, they will have paid, and so on and so forth. Now at some point you might be wondering, how am I able to write these numbers so fast? If you observe, the sum of any two players who are playing in this round is equal to 2 plus 1, 3. So which can be written as 2 to the power 1 plus 1. The sum of any two players, 3 plus 2, 5, 4 plus 1, 5. This can be written as 2 square plus 1. The sum here is 6 plus 3, 9, 7 plus 2, 9, 4 plus 5, 9, 8 plus 1, 9. So this is equal to 2 cube plus 1. Similarly here the total will be 2 to the power 4 plus 1. Here it will be 2 to the power 5 plus 1, 2 to the power 6 plus 1, 2 to the power 7 plus 1. So over here the total should be equal to 129, this will be 65, this will be 33, this will be 16 plus 1, 17, this is 8 plus 1, 9, this is 2 to the 4 plus 1, 5, and this is 3. So these are the totals for various rounds. Now why am I looking at this total? See, the thing is that, let us say I have to find who will be playing with player seeded 15 in this round. In order to find the person who will be playing with player seeded 15, all I need to do is, this is 15, the total has to be equal to 33. If the total has to be equal to 33, 33 minus 15 is 18. So the other player will be player number 18. In the round before this, the total is 65. If the total is 65, so 15 and 50 will be together, and 18 and 47 they will be together. And similarly for the last round also. So if I have understood this one thing clearly, I would be able to recreate the table for the earlier rounds simply using this idea. And that is more or less the crux of this DI set. Now let's take a look at the questions. Question 1, what is the total number of players taking part in the tournament? In the tournament, the total number of rounds is given as 7. If the total number of rounds is 7, that means that here the last seeded player, he should have been 128. However, because if there were 128 players, all the players would have played with each other, but that is not the case. What is happening here is that 1 to 8 they have got a bye. If 1 to 8 have got a bye, that means that the number of players was 8 less than 128. So if the number of players is 8 less than 128, 128 minus 8, 120, option C will be your answer. That was question 1. Question 2. What is the number of matches won by the winner of the tournament? As far as the number of matches won by the winner of the tournament is concerned, if we assume that the winner is one of the persons who has been playing from the first round, then he will have played an overall 7 rounds, because for every round he will have to play one match. However, in case the winner of the tournament is one of the players from players seeded 1 to 8, then he will not have to play in the first round, and if he does not have to play in the first round, then he can be the winner of the tournament even if he has played just 6 rounds. So 6 or 7, any of the two possibilities is there. Answer would be cannot be determined. At this stage, I would also like to ask what is the total number of matches in the tournament? If we know that the total number of players is 120, then what is the total number of matches that are played in the tournament? The answer will be 119. We should always remember this, that the number of matches in a knockout tournament is always n minus 1. So the number of matches in a knockout tournament is always n minus 1. So where n is the number of players, so the number of matches is always n minus 1, where n is the number of matches. You may ask why. The idea is that finally, whatever may be the number of players, finally only one person is going to win the tournament. So that means that rest everybody will have to be eliminated. Now in order to eliminate one person, I need exactly one match, and alternately in every match one person gets eliminated. So therefore, in order to eliminate n minus 1 people, I will need to play n minus 1 matches. So therefore, n minus 1 is the number of matches, now and always.
This is a set on a tournament where we know that we have 12 teams which are divided into 2 pools of 6 each. It is given that at the pool stage, each team in a pool plays with every other team in the pool, and then the top 3 teams based on the score or net run rate, and it given that there is a no tie that happens, either a team wins or loses, and based on the score or net run rate, the top 3 teams from each pool advance to the Super 6 stage. From at the Super 6 stage, each team in a pool from this pool plays every other team, and then the top 2 teams in each of these 3 from amongst each of these 3 reach the semi-finals. So the winners of these semi-finals reach the final, and there will be one winner eventually at the end of the tournament, right? That's the format of the tournament that we have, and the question that we have is, what is the total number of matches in the tournament? How many matches will be there? We know that there are 6 teams in each pool, and there are 2 such pools. So each team plays every other team, so 62 matches in each pool, so 62 into 2 here. That is one way to do it. Or you can also arrive the number of matches in each pool by saying that there are 6 teams and each team plays every other team. So the top team you count for 5 matches, so next team 4 matches, 5, 4, 3, 2, 1. That will also add up and give you the same value. And then in the Super 6 stage, there are 3 teams here and there are 3 teams on the other side. So 1, 2, 3 here, 1, 2, 3 here. So each team plays 3 matches with every other team. So that means there are a total of 9 matches here. So 62 into 2, 62 is 6 into 5 by 2 into 2. So that means we have 30 matches here and we have 9 matches. We have 2 semi-finals and we have 1 final match. So that is a total of 42 matches. 39 plus 2, 41 plus 1, 42 matches in the tournament. What is the minimum number of wins required for a team to advance to the Super 6 stage? Now, how many teams advance to Super 6 stage? From each pool, there are 3 teams that advance to the Super 6 stage. Now, out of the 3 teams that advance, we need to send one team with the least possible wins. Now, we know every match ends up in a win because there is no tie. One team is winning, one team is losing. So, and every match ends up in a result. So, which means we need to try and minimize the number of wins for this team. Now, how do we do that? We try and minimize the number of wins here by try and maximize in the pool stage, because there are 15 matches in one pool, the total of 15 matches, which means there are 15 victories. So, this 15 victories we will try and give as many of them as possible to the top 2 teams, so that the remaining wins we will try and distribute among the remaining teams, so that one of these can get through, one of the remaining 4 can get through. So, how many wins can the top team have? The top team can have 5 victories. It wins on each of the all of its opponents, and then the next team can have 4 victories. It will lose one with the one above. So, which means there are the remaining 6 matches that are there. Now, these 6 matches have to be distributed between 4 teams. Now, if the 6 matches are to be distributed between 4 teams, we can say each team will have 1 win each, let's say. So, if we distribute 1 win each to each of these teams, there are still 2 wins that need to be distributed. Now, these 2, because there are no ties, these 2 have to be wins. Now, whichever team gets those wins will get through. These 2 wins can come to this team, so it can get through with 5-4-3, or the other way is that it instead we can distribute it as 1+1 and 1+1 to these 2 teams. So, between these 2 teams, net run rate will come into play, and one of these teams can advance to the Super 6s. So, which means a team can advance into Super 6 stages with only 2 wins. 3 wins is not necessary, 2 wins is sufficient. What is the maximum number of matches won by a team that failed to reach the semi-finals? Now, here we need to give as many victories as possible to a team and still stop it from reaching the semi-finals. Now, how can that be possible? Now, we know that in the Super 6 stage, the movement to the semi-finals happens from the Super 6 stage, and in the Super 6 stage, only the top 2 teams go in, the 3rd team stays out. Now, if at the Super 6 stage we have a scenario where all the 3 teams are the same at score, in terms of score, and if differentiation is done on the basis of net run rate or net score as is being given in the set, then one of the teams can stay out. Now, which means till the Super 6 stage, till the end of the Super 6 stage, all the 3 teams should have the same score, which means the teams should get the same performance in the Super 6 stage, same maximum performance, which means the teams should win all the 3 matches in the Super 6 stage. So, we have 3 victories at the Super 6 stage. Now, which means that the teams before going into the Super 6 stage also should have the same score, which means at the end of the pool stage, the teams should have the same score, which means the same number of victories. So, what is the same number of victories with which the teams can go in? So, there are 15 matches in the pool stage, which means can the teams go in at 5, 5 and 5 each? No, because for a team to have 5, 5 and 5 victories each, it should also be playing amongst those, meaning team A should be playing team B and ABC should be playing amongst themselves. So, they cannot have equal number of victories. So, the equal number of victories can be possible only if there are 4, 4 and 4 victories. So, top team will have 4 victories, the next team will have 4, and the team after that will have 4, and the remaining 3 victories will be shared by the teams at the bottom. 5, 5 and 5 is not possible, because what about the teams? If the total number of victories that are available are taken by these 3 teams, then what will these teams do? What about the matches that these teams play amongst themselves? So, these teams also, for example, this team playing with this team has to result in a victory, which should again come out of this 15 victories here. So, 4, 4 and 4 is a possible scenario with these 3 teams sharing the remaining 3 victories. So, 4 matches in the pool stage, and then they go to the Super 6 stage, they win all the matches in the Super 6 stage. So, 4 plus 3, 7 victories for each of the teams in the Super 6 stage. They are at 7 victories each. Now, out of these 3 teams, only 2 teams will move into the semi-final stage, which means one of them has to be left out. It will be left out in spite of having 7 victories. So, 7 is the maximum number that a team can get and still fail to reach the semi-final stage. This question, we have a game which involves picking coins. We have 2 people, Anand and Sunil, who are playing this game, and it's given that each player in his turn has to pick up a minimum of 2 and a maximum of 6 coins. Minimum 2 coins, maximum 6 coins, and that is the information that is given to us. And except that when there is only 1 coin left, in which case the player whose turn it is, he has to pick that 1 coin which is there, and the game continues till all the coins are removed from the table. And for the first 3 questions, we have the rule which says that the player who picks the last coin loses the game. Now, the player picking the last coin loses the game, and if we look at the question says if the game starts with 52 coins and it's Anil's turn to play, and how many coins should he pick up so as to ensure his win. Now, we need to understand when does a player win and when does a player lose. We know that in this question, we know that the player who picks the last coin loses the game. Now, which means that we need to understand at which number is a player likely to lose and at which number is a player likely to win. So, if I get a table with 1 coin, I am forced to pick that coin and I will lose the game, because the player picking up the last coin loses the game. The same thing happens when I get 2 coins also? Yes, because I have to pick up a minimum of 2 coins. But then if there are 3 coins, there is a table which has come to me with 3 coins, then what can I do? I pick up 2 coins and send the table back to my opponent with 1 coin and force him to pick that coin. So, I will win the game. Now, if I get the table with 4 coins, I do the same thing again. I pick up 2 coins and send the table. I make the table a losing scenario. 3, if I get 3 coins, I pick up 2 coins and make it a losing scenario. If I get 4 coins, I pick up 2 coins, send it to my opponent. If I get it with 2 coins, I lose. If my opponent gets it with 2 coins, he loses, because it's given that both the players play to win the game and they are smart. So, if I lose at a number, my opponent also loses at that number. So, if I get the table at 4 coins, I pick up 2 coins and I win. If I get a table with 5 coins, I pick up 3 coins or 4 coins and give a losing table to my opponent, so I win. 6 coins, I pick up 4 coins or 5 coins and I win. 7 coins, what happens when there are 7 coins? I can pick a maximum of 6 coins, so I pick 6 coins or 5 coins and make it a losing table, so I win. 8 coins, I can pick 6 coins, so I can still make it a losing table, so I win. What happens when there are 9 coins? When there are 9 coins, the maximum number of coins that I can pick is 6. If I pick 6 coins, then the table still remains a winning table. If I pick 2 coins, which is the minimum, then there are 7 coins on the table and it's still a winning table. So, when I get a table with 9 coins, I can only make a winning table. I cannot make a losing table, so I lose. If I make a winning table for my opponent, it means I lose. Similarly, when there are 10 coins, if I pick 2 coins, the table is still a winning table that I am giving to my opponent. If I pick 6 coins with 4 coins, it's still a winning table that I am giving to my opponent. So, both the cases are winning for my opponent, which means it's a losing case for me. Now, 9 and 10 are a losing case. Now, continuing this, now to what extent should I continue? I understand, looking at this distribution, you can see that 1, 2 I lose, 1, 2, 3, 4, 5, 6 I win, and then 2 I lose. Now, you see that we are getting into this pattern 2, 6, 2. So, the next 6 will be winning again, the next 2 after will be losing again. Now, how is that possible? That is possible because whenever I get a table, I only need to take the table to the closest losing scenario so that I can win. For example, if I get a table with 15 coins here, now all I need to do is to bring the table down to 9 coins or 10 coins. So, which means I can pick 5 or 6 and make it a losing table. 14, pick 4 or 5, make it a losing table. 13, pick 3 or 4, make it a losing table. If there are 17 coins, if there are 16 coins, I can still pick 6 and make it a losing table. If there are 17 coins, so 17 coins, the max that which is 11 is a winning scenario for me. 11, 12, 13, 14, 15 and 16, all of these are winning scenarios for me. 17 will again be a losing scenario, 18 will again be a losing scenario, so on and so forth. Now, if you notice 2, 6, 2, 6, 2. So, this is the pattern in which the losing scenario follows. Now, what is this? When are we getting a losing scenario and when are we getting a winning scenario? Now, if you see, this is 8, 8 plus 1 and 8 plus 2 are losing scenarios. 2, 8, 16, 16 plus 1, 16 plus 2 are losing scenarios. You can see that any number which is a multiple of 8 plus 1 and plus 2 will be losing scenarios. The next one will be 24. 19 to 24 will be winning scenarios. 25 and 26 will be losing scenarios. So 8k plus 1 and 8k plus 2. These will be the losing scenarios. Now what is this 8? Where did this 8 come from? 8 is nothing but addition of 2 and 6. So if you get a question where these numbers change, you know what to do with this multiple. This 8 is nothing but the addition of the minimum coins to be picked and the maximum coins that can be picked. Now this is the number that we need to watch out for to avoid a losing scenario. So let's look at the question here. If the game starts with 52 coins and it's Anil's turn to play, then how many coins should he pick up so as to ensure his win? Now there are 52 coins on the table. Now to ensure that Anil wins, now what should Anil do? Anil should convert this 52 into a losing table, which means he should convert this 52, he should pick some coins and leave that many coins on the table in this form. The number of coins remaining on the table should be in this form, 8k plus 1 or 8k plus 2. So which means we need to look for the closest multiple of 8 less than 52. Obviously less than 52, not greater than 52, because we are removing coins, so number will only fall. So the closest multiple of 8 to 52, which is less than 52, is 48. So 49 coins or 50 coins will ensure that Anil is giving a losing scenario to his opponent, which means Anil will win. So 49. So to make it 49 coins, Anil should pick up 3 coins. To make it 50 coins, Anil should pick up 2 coins. So 2 coins or 3 coins, which is option D, will be the answer for this question. In the next question, which of the following can be the number of coins on the table before Anil's turn to play if it is known that Sunil would win the game no matter how many coins Anil picks? Now the options we have are 72, 62 and 89, and there is a none of these. Now we need to understand the question properly. Which of the following coins can be the number of coins on the table before Anil's turn to play if it is known that Sunil would win the game? Now if Sunil is winning the game, no matter what Anil plays, it means that Anil is getting a losing table. Now if Anil is getting a losing table, all we need to do is to find out which of these is a losing table, which means we need to find out which of these are is in the format 8k plus 1, 8k plus 2. Now very clearly you can see that 89, which is 88 plus 1, is 8k plus 1, which means that if there are 89 coins that Anil gets, no matter what he does, he has to lose because it's a losing scenario. This question we have, if the number of coins to be picked up on Sunil's turn so as to win the game, no matter what Anil plays, is 5, which means the number of coins to be picked up no matter what Anil does is 5, which means Sunil is winning no matter what Anil does, which means Sunil is sending a losing scenario to Anil. So then which of the following could be the number of coins on the table? Let me read the question again. If the number of coins to be picked up on Sunil's turn so as to win the game no matter what Anil plays is 5, then which of the following could be the number of coins on the table? We know Sunil is picking up 5 coins. The question is, how many coins are there on the table before Sunil picks up those 5 coins? Now we know that Sunil is giving a losing scenario to his opponent, which means Sunil is converting, by picking up those 5 coins, he is converting this table into a losing scenario, which means after picking up 5 coins, this table is becoming a losing scenario, which means 22 minus 5, 17, 42 minus 5, 37, 69 minus 5, 64. One of these should be a losing scenario, which means it should be in the form of 8k plus 1 or 8k plus 2. Now which of these is in the form of 8k plus 1 or 8k plus 2? Very clearly 17, 16 plus 1. So which means the number of coins that Sunil had before he started his game is 22, from which he picked 5 coins, made it a 17 coin table, which is in the format 8k plus 1, and therefore is a losing table for Anil. So no matter what Anil does, Sunil has to win. Now we have a variation in the rule. Now the rule says that the person who picks up the last coin wins the game. Now if the person who picks up the last coin wins the game, we know that if there is only one coin on the table, the last person wins the game. If there are 2 coins on the table, the last person wins the game, because in spite of the minimum being 2, whenever we know that whenever there is only 1 coin, the person has to pick up that coin, and therefore he picks it up and wins. When there are 2 coins, he can pick it up and win. So we know, because he can pick up a max of 6 till 6 coins, we know the person wins the game. Now when there are 7 coins on the table, the max that the person can pick is 6. So when there are 7 coins, he will leave 1 coin for his opponent, and therefore his opponent wins. Or if he picks up the minimum number of coins, from 7 he can only make it 5, and his opponent can pick his 5 and win, which means 7 is a losing scenario. Now look at 8. Maximum is 6, so he leave 2 coins on the table, the opponent wins by picking up those 2 coins. If he instead picks only 2 coins, then he was giving his opponent a 6 coin table, and his opponent can pick all the 6 coins. So 8 is also a losing scenario. Now instead, if there are 9 coins on the table, what will happen? If there are 9 coins, the maximum number of coins that I can pick is 3, which means I can give my opponent a winning table. But instead, if I only pick 2 coins, if I pick 2 coins, I will give my opponent a 7 coin table, and I know that a 7 coin table is a losing scenario. So I will make sure that I pick only 2 coins and give my opponent a 7 coin table, which means all I need to do is to change the table to the nearest losing scenario. Because I can pick 2 coins, I can make it a losing table. Similarly, when it's 10, I can still make it a losing scenario. So for the next 6 cases, so it will be a winning scenario. And we know from what we have discussed in the last rule that the next 2 will be losing cases, and it will be followed by winning cases. So what's the pattern that is emerging now? Winning till here, losing these 2. So what is this 8? Earlier it was 8k plus 1 and 8k plus 2. Here it is 8k and 8k minus 1. 8k is 16, 8k minus 1 is 15. So the ones to look out for, or the losing scenarios, are 8k and 8k minus 1. Now with that understanding, let's look at the question in this. How many coins should Anil pick up to ensure his win if there are 100 coins on the table? If there are 100 coins on the table, I need to get it to the nearest 8k or 8k minus 1. The nearest 8k to 100 is 96, nearest 8k minus 1 to 100 is 95. So Anil needs to pick up either 4 or 5 coins to make it a losing table so that he can win. Looking at the next question, if the number of coins Sunil picked up in his turn to ensure his victory was 2. So by picking 2 coins, Sunil converted the table into a losing table. Then which of the following coins could have been the number of coins on the table before his turn? Now if you look at the first option, 33 coins. If 33 coins were there on his table, after picking up 2 coins, it becomes 31. And we know 31 is in the format 8k minus 1, which means it is 33 coins that will definitely, and that could have been on the table before his turn to play. But then because there is a more than one of the above also in the options, we will have to evaluate the remaining 2 options also. 67. If there is 67 and if he picks up 2 coins, he will end up with 65. 65 is not 8k or 8k minus 1. 65 is 8k plus 1. So it's not possible. 101, after picking up 2 coins from 101, it will be 99 coins on the table. So 99 is also.
Good day. This session will be one of your first sessions on logical reasoning. In specific, as you can see, we'll be dealing with linear arrangements. Now, when you talk about arrangements for our B school entrance exams, arrangements could be those kinds of puzzles where we are required to typically arrange people, let's say. They could be having some names, or we could just be looking at alphabets as their names. Let's suppose that we're looking at 5 people A, B, C, D, E who have to be arranged in a linear fashion. Now, when we talk about a linear arrangement, remember that the linear arrangement could either be a horizontal arrangement or it could be a vertical arrangement. Either way would be a linear arrangement. Now, in any case, what we have to keep in mind is your puzzle will consist of certain basic data and certain conditions that we have to keep in mind before we arrive at appropriate arrangements for the given individuals in the puzzle. What do I mean by saying this? Now let's simply suppose that you're looking at arranging 5 different people A, B, C, D, E horizontally to start with. If you have to arrange 5 different people A, B, C, D, E horizontally, then your puzzle will also contain, let's suppose that this is your basic data. Your puzzle will also contain additional constraints that we also have to ensure are satisfied. So you could be looking at constraints something like A and B don't really get along well, so you cannot position A and B next to each other. So that could be a constraint. So we have to keep in mind that whatever final arrangement or arrangements we arrive at, factor into account all the possible constraints given in your puzzle. So the final arrangement or arrangements, the possible arrangement or the different possibilities should be those that encompass and satisfy all the given constraints too. Now, before we look at solving a couple of puzzles, let's just understand certain basics about how these constraints are written and how we need to understand these constraints. Now, say for example, you're looking at 5 people, let's say you're looking at 5 people A, B, C, D and E. Let's assume that we have to arrange them in 5 different seats in a horizontal fashion. Now, supposing one of the constraints says something like A should be seated to the left of B. Now, when A is seated to the left of B, how do we understand what is left? Is the left that we are talking about my left as I am facing you, or is the left we are talking about your left the way you're facing the screen? So effectively, what left are we talking about? So this could raise a possible confusion. So remember that we go by certain standard conventions, the first of them being when you're not really given in which direction these people are actually sitting or facing. Take it for granted that all positions are pointing north, which means that this is your north, this is your east. So take it for granted all positions are facing north. So here it doesn't really matter now whether it's going to be your left or whether it's going to be my left. Any left would be a left as such because all the positions are facing north. So how do we understand something like this? A is to the left of B. Now in this arrangement we could be looking at A being to the left of B, which means that let's suppose that B is here, then A would be here. A is to the left of B because both of them are facing north. Likewise, we could also be looking at A here and B positioned here. This would also mean that A is to the left of B. Or you could have A here and B in the fourth slot. Or you could have A here and B in the 5th slot. Or you could have A in the 2nd slot, B could be in any of the remaining 3 slots. So effectively, what do we understand by this constraint that says A is to the left of B? Understand that left of a person is different from somebody being immediately left to another person. So there's a fundamental difference between who is left versus who is immediately left of a person. So left could imply immediate left also, but immediate left obviously would not imply mere left. It has to be an immediate left. Now, supposing you're looking at a constraint that says A is 3 places away from B. Now treat these 2 points as independent of each other. So let's suppose that we have again 5 slots that we need to fill in with A, B, C, D, E, and one of the other constraints says that A is 3 places away from B. Now what does this mean? Supposing we have A over here, 3 places away would mean this is your first position and these positions are labeled 1 through 5. So 3 places away from B, so where would actually be now B? So this is your first position, second, third. So effectively what we are saying is B should be somewhere over here. In other words, remember that when any person is n places away from another person, then essentially there have to be n minus 1 positions that separate the two. This is how we understand somebody being away from another person. Now this particular constraint does not really talk about if A is 3 places to the left of B or if A is 3 places away to the right of B, which means that you'll have to factor into account both the possibilities. So if this is a possibility, then another possibility also can be B is over here and A is here. These are also likely possibilities. Similarly, you can also have A or B in the 2nd position, while B or A will then be in the 5th position. So you have to factor into account all the possible ways of arranging something. In other words, remember that when you come across solving these kinds of puzzles, you're not just constraining yourself, you're not just zeroing in on identifying only one possible way of arranging or only one possibility that will satisfy the constraint. You have to look at all the possible ways in which that constraint could be satisfied. Now let's look at how we apply this information in solving linear arrangement puzzles. Now as you can see on your screen, you have a simple puzzle. you might want to pause the video and try solving the puzzle for yourself, or let me just walk you through about how to handle this puzzle. So you might want to try another puzzle at a later time. Now, the puzzle says something like 7 persons P through V are sitting in a row facing the same direction, not necessarily in the same order. Because if they were sitting in that particular order, then there would really not be any puzzle. So the first takeaway from this puzzle is we have 7 people starting from P through V. P, Q, R, S, T, U and V are 7 people who we need to arrange in 7 different slots. The following information is known. Now, understand one thing very fundamentally. There could be any number of constraints given to a puzzle. Those constraints could be numbered, or they may just be given as a single paragraph. Moreover, there need not be any particular order in which you choose to apply a particular constraint in trying to arrive at your solution. You can choose any constraint depending on your convenience as what may deem fit as your starting point. So there needn't have to be a particular order that you need to follow in choosing the constraints to solve the puzzle. So here there are 4 different clues given, constraints given. You could be choosing any of them to start with. Now, recommendation would be to start with clue number 4. Clue number 4 reads, Q sits 2 places away from U, who is at one of the ends. So ideally we pick up a clue where at least one of these 7 positions is fixed. That will be a good start. Now we are given that U is at one of the ends. Now one of the ends could be either to the left end or to the right end. So to factor both the possibilities into account, in one case we will look at U being to the left. Remember, left here again means that left where everyone is facing north. Or the other end could be to the right end. So this could be U. Q sits 2 places away from U. Now somebody sitting n places away from another person would mean that there are n-1 positions separating them. So if Q is sitting 2 places away from U, Q should be here so that there is 2 minus 1, 1 position separating U and Q, or Q is here, 1 position separating U and Q. So that takes care of the 4th constraint. Now we have 3 more constraints. Now let's look at the first constraint, because it will now be a lot more easier for us to arrive at those particular clues in the puzzle that talk about U and Q. So that we'll be able to use these as relative positions and then accordingly arrange the other unknowns. So clue number 1. The number of persons sitting to the left of Q is equal to the number of persons sitting to the right of S. Now, number of persons sitting to the left of Q is 2. As per this clue, the number of persons sitting to the right of S must be 2. So S could be here. Similarly, if it were this case, the number of people sitting to the left of Q is 4. Similarly, the number of people sitting to the right of S must be 4. So effectively, you need to have S over here. So there are 4 people to the right of S. That takes care of clue number 1. Third clue. S sits third to the left of R. S is sitting third to the left of R. Now, if you are looking at this possibility, S should be sitting third to the left of R. So even if you put R here in the extreme right, this would only be 1, 2. This would only be the second position to the left of R. So which means that this is not definitely a possible way of arranging our unknowns. So we look at this possibility. If S is here and S is third to the left of R, obviously R must be here so that first, second, third to the left of R has been taken care of. So that takes care of clue number 3. Look at clue number 2. P sits exactly between R and T. P should sit exactly between R and T. Now when we come across these kinds of somebody sitting exactly between somebody else, it means that P, the number of positions of that person who's sitting in the middle, taking that person as a reference, the number of positions to that person's left and to that person's right must be equal. That is what exactly in between means. So it says P sits exactly between R and T. So P should be between, exactly between R and T. Now, where would we actually place P such that P is between R and T? Put P here so that between P and R there is 1 position separating them. Automatically T comes here so that there is 1 position separating P and T. So needless to mention, the only other unknown that is left out is V. So V will take the first position. that takes care of only one possible arrangement satisfying all the given constraints. Now with this, we should be able to answer any sorts of questions. Now take a look at your questions. Question number 1 says, who sits at the left end of the row? Who sits at the left end of the row? Needless to mention, it has to be V. Question 2, who sits to the right of R? Now remember, somebody sitting to the right of R need not necessarily be somebody who's sitting immediately to the right of the to the right of the person. But here, who is sitting to the right of R? Here, right obviously means immediate right, because there are no other positions other than immediate right to R. So the answer to this question must be U. Third question, how many persons are sitting between T and R? Between T and R, the number of people sitting are 3. That should answer your question. So this is how we actually apply certain elementary knowledge to understand and solve these kinds of puzzles. Let's look at solving another puzzle. On your screen you have the puzzle. You might want to try it on your own by pausing the video, else let's just do it together. Now the puzzle says 7 girls, P, Q, R, S, T, U and V are seated in a row facing the same direction. So you have 7 girls, P, Q, R, S, T, U and V, that we need to arrange in 7 slots, all of them facing the same direction. Now when it says all of them facing the same direction, needless to mention, we take it for granted that all of them are facing north. The following information is known about them. Now you're again given 4 different clues as such. Try to spot one particular clue where maybe one of these 7 positions is fixed. Let's just scan through these clues and see if we can identify a clue that fixes one of these 7 positions. Now if you look at clue number 2, it says T is at the left end and S is to the right of U. This is a clue where we are at least fixing one particular position. T is at the left end. S is to the left of U. Now always make it a habit when you're solving puzzles to try translating these clues into certain mathematical symbols or notations that you feel are comfortable to understand the clues as such. Because when you're actually solving these puzzles in the exam, it may not be possible for you to refer to the question paper or to the screen, whatever be the exam pattern, time and again to just look at what the entire sentence of the clue is. It's always easier for you to look at a quick shortcut way of understanding a clue. Let's see how we do that. Now this says, clue number 2 says, T is at the left end and S is to the left of U. How do we understand that? S is to the left of U. This is how you understand it. This is how you write it. Supposing the clue said S is to the immediate left of U, you would simply write it as less than or equal to understand that somebody is immediately to the left. Likewise, right would mean greater than symbol. Immediately right would mean greater than or equal to. So this is how you can actually create some sort of elementary notations to understand what these clues stand for. S is to the left of U. Look at the first clue now. R is 3 places away to the right of U. R is 3 places away to the right of U, which again means that U is to the left of R. And there are 2 positions that separate U and R. So this is what we understand. Then clue number 4 says R is to the right of both P and V. So R is to the right of both P and V again means that R is to the right of P and V, or P and V are to the left of R. Now remember, when he says that the clue says P and V are to the left of R, that does not necessarily mean that P is to the left of R. It need not be in that respective order. It can be in any order. We have to keep that in mind. Clue number 3. If Q and S interchange their positions, each of them gets exactly one new neighbor. Now, when is it a likelihood that when you interchange 2 positions, they get exactly one new neighbor? That is possible when, in one case, they are actually at the extremes. They are the endpoints. But that is not a possibility here because you already have T taking over one of these endpoints. Another possibility can be where both of them already share a common neighbor, so that even if you interchange those 2 positions, they will only get one more new neighbor on the other direction. That's how you have to understand clue number 3. Now let's combine all these clues and try to arrive at solving this puzzle. Now look at the first clue again that says R is 3 places away to the right of U, which means that between U and R there have to be 2 positions separated out. Now let's look at all the possible ways of doing it. Now let's suppose you push R to the extreme right. For example, let's do it this way. Push R to the extreme right. Number of positions separating R and U now must be 2, so we will fix U here. All right. Now you might ask a question. Why can't we shift R to, let's say, this position and have U at this position? That's a possibility. So far it's a possibility. Now, in this sort of an arrangement, you also have to factor into account the fact that S is to the left of U. So here the possibility of S being to the left of U is S being immediately to the left of U. Now, we also have a clue that talks about Q. If Q and S interchange their positions, each of them gets exactly one new neighbor. Now, S is here, unless of course S and Q share one common neighbor, then interchanging their positions will not result in exactly they sharing exactly one more new neighbor, which means that in this case the only possibility being Q being here, so that even if you interchange these two, both of them will still have a common neighbor U. But when Q comes here, Q will have a new neighbor T. When S goes here, S will have a new neighbor, whoever it is, onto S's right. So you should ensure that S and Q share a common neighbor. So far, so good in this arrangement. Now let's see if we can pitch in the others also in this arrangement. Now we also have one clue that says P and V must be both to the left of R. If P and V must be both to the left of R, we only have one position to the left of R remaining. We cannot factor into account both these positions, both these people into one position. Hence, this is not a possibility, which means that R is at best on the extreme right. Now, let's again fix R in the extreme right and U is here, and look at all the different ways of solving this puzzle. One possibility is where S is to the left of U. Let's assume Q is here, ensuring that both of them share a common neighbor, so that even after interchanging their positions, they will only have one more new neighbor to the respective left and to the respective right. Now, both P and V must be to the left of R. If P and V must be to the left of R, now remember that this could be P, this could be V, or this could be V, this could be P. In any case, both of them are to the left of R. So this is one definite possibility that satisfies all the constraints. Now let's see if there's another way to do it. Now another way to be solving this puzzle would be to try looking at fixing S here to the left of U, and then can we place Q here? Now if you interchange both of them, they will only have a new neighbor, because these two are anyway neighbors to each other. Even if you interchange both the positions, they will only have another new neighbors, which will be T or U. The same happens even if you interchange these positions. And also P and V must be to the left of R in any order. So essentially, this is ruled out, this arrangement is ruled out. From this arrangement, we have two different ways of arranging it. One with PV, one with VP. There are two different possibilities. Here you can see that there are four different ways of arranging these 7 people satisfying all the constraints. So the final shortlist would be these two in all permutations. Now we should be able to solve these questions. Look at question number 1. If S sits to the immediate right of P, if S is sitting to the immediate right of P, where would that happen? Definitely not here, because P and V are somewhere here. It has to be only here. So if S has to be to the immediate right of P, P must be here, then automatically V will be here. So in this arrangement, who will be to the immediate left of V? Who is to the immediate left of V? Your answer should be Q. That should take care of first question. Question number 2. If Q and S are not adjacent to each other, so if Q and S are not adjacent to each other, which again means these two possibilities, then in how many ways can these 7 girls be seated? 2 different ways of making this arrangement. Next question. If U sits to the immediate left of P, U is sitting to the immediate left of P. That's possible in this case. Where you fix P here, automatically V is fixed here. U is to the immediate left of P, then who will be second from the right end? From the right end, who will be second? First and second, so second must automatically be V. That takes care of your third. Hello there. This session will be on how we solve questions involving calendars. Now, the kind of questions that will be usually asked on calendars would be something like this. We could be given a reference point of time based on which we'll be asked to find out the particular day of a week of another day and another year. Say for example, you said that 1st of August 2013 happens to be some day of the week. Then what would the 4th of November in 1976 be? So you're given a reference point and a particular day of the week, based on which you will have to actually calculate and find out what the day of the week for another reference date and year would be. Now you might be wondering, is it not easy for us just to Google search for something like this and find out what the day of the week is? Well, in reality, that's how simple it is. You can always find the day of the week by searching on Google, but the exams don't really expect us to use Google. So we'll have to find out logical methods on how we arrive at particular days given a particular date. Now, there are two different kinds of questions that could be tested here. Number one type, where you're given a reference point and then asked what day of the week would another particular reference point be. Say for example, you're given that 1st August 2013 happens to be some day of the week, then what would 4th November 1976 be? What day of the week would that particular date be? That would be one kind of a scenario. Another kind of a model would be where we are not given any reference point, but we are straight away asked to find out what day of the week would, let's say, 4th of November 1976 be. So something of that sort could be asked in these business school entrance exams. We'll look at how we work out on both these different kinds of models. We will use a logical approach. We will also look at how we solve these using a simple formula. Now let's just have a quick overview of some basics that are required to understand these calendar problems better. First point, we all know that there are 7 days in a week. That's a very standard understanding. Number two, a weekday repeats after every 7 days. What do we mean by this? Say for example, today is, let's say, some particular day of the month. Let's say today is the 1st of the month. If today is the 1st of the month and it happens to be a Monday, then after 7 days you're going to get another Monday, which means first date plus 7 days would be the 8th of the month. 8th of the month would again be a Monday. That's exactly what point number 2 says. Point number 3 is an important concept which we'll be using very often, called as odd days. Now remember that odd days, the term odd days is used to reference to the remainder that is obtained when the reference number of days is actually divided by 7. Say for example, you are asked to find out how many odd days are there in the month of May. Now we know that May has 31 days, so the number of odd days in the month of May would be the remainder of 31 divided by 7, which is actually 3. Or in other words, what we are effectively saying is the month of May has a total of 4 complete weeks. So that makes it 4 into 7, 28 days, and then we have 3 days which are remaining or left out. So this 3 days is what we refer to as odd days. Now let's just have a quick understanding of this concept of leap year. Now there are two different ways in which you need to understand how you recognize or identify leap years. One, when you're talking about non-century years like 2015, 2014 and things like that. The other being century years. Century years are years like 1600, 1800, 1900, 2000 and things like that, or 2100, so forth. They are century years. Now when you're talking about non-century years, remember that when the non-century year is divisible by 4, you recognize that that particular year is a leap year. But when you're talking about century years, remember that that century year must be divisible by 400 and not just by 4. It will not suffice if 4 divides a century year, because we anyway know that 4 would divide any number that ends in 2 zeros. But what we need to check for is that number divisible by 400. Say for example, you're looking at 2014. The year 2014 is definitely not a leap year because it is not divisible by 4. The year 2000 was definitely a leap year because 2000 is divisible by 400. The year 1900 is not a leap year because it is not divisible by 400, though divisible by 4, though divisible by 100, it is still not divisible by 400, so this is not a leap year. Likewise, 1796, the year 1796 was a leap year. This is how you recognize years as leap years or non-leap years when it comes to century years or non-century years. Another very important concept is on day gain or day loss. Say for example, we are looking at two different types of years again. We are looking at non-leap years and leap years. Let's understand what this concept is for non-leap years to start with. When you talk about non-leap years, say for example, you're saying that 1st of August 2013 is a Thursday. Then you're trying to find out what day of the week will 1st of August on the next year would be. Now 2013 to 2014, your dates are the same. Now understand that 2014 is a non-leap year. So here we need to understand that for the non-leap year, for the same date of the subsequent non-leap year, the target year which is 2014, the day gain would be simply one day over Thursday, which means the day of the week for 1st August 2014 would be a Friday. The same holds good even when you are backtracking from 1st August 2014 to 1st August 2013. So there you're talking about a day loss. So if 1st August 2014 is a Friday, then 1st August 2013, because this happens to be a non-leap year, would be Friday minus 1, that would be a Thursday. So this is how we understand it for non-leap years. For leap years, it's slightly different. If you're talking about leap years, let's understand this again with an example. Let's say 11th of June 2015 is a Thursday. Then what day of the week would 11th of June 2016 be? Now what we need to understand here is this. Our target year 2016 is actually a leap year because it is divisible by 4. Now for leap years, the rule is slightly different. For leap years, what we do is we'll have to add 2, or there is a day gain of 2 days of the week. So if 11th June 2015 happens to be a Thursday, 11th June 2016 would be Thursday plus 2, so it will have to be a Saturday. The same holds good in the reverse fashion also. Now the exception to the rule is this. Remember that your target year, the day and the month of your target year must have crossed 28th February as such. If it has not crossed 28th February of that target year, then there will not be a day gain of 2 days, there will be a day gain of only 1 day. Say for example, 26th January 2011 happens to be a Wednesday. Then 26th January 2012. Now 2012 is a leap year to start with, that's number 1. Number 2, 26th January did not cross 20th February of 2012, our target year. Then in such a case, our day gain is only 1 and it is not 2 as such over Wednesday. So the day of the week would only be Thursday in this particular scenario. Now let's see how we apply this understanding to certain questions that you could be looking at, certain models of questions that you could be looking at in any of these B school exams. Now this question reads thus: if 15th August 1984 is a Wednesday, then what day of the week will 23rd September 1990 be? So here this is one variant where you're given a reference date and the year and the day of the week, based on which we are asked to arrive at the day of the week for the target date and the year. Now we are starting with 15th August 1984. Now from 1984 to 1990, let's say you have 1985, the years are 1986, 1987, 1988, 1989 and 1990. These are your years starting from 84 to 90. Now you're given that this date happens to be a Wednesday. Now a little while back we've seen how day gain and day loss work for successive years when you're talking about leap years as well as non-leap years. So here in this case 1985 is a non-leap year, your target year is a non-leap year in this case. So if 15th August 1984 was a Wednesday, 15th August 1985 should have gained 1 day over Wednesday. So this should actually become Wednesday plus 1, it should become Thursday. Likewise 15th August 1986 also being a non-leap year should actually become Thursday plus 1 day, so it should become a Friday. Likewise 1987 also being a non-leap year would become Friday plus 1, this would become a Saturday. Now 1988 is actually a leap year because 1988 is divisible by 4. Now for leap year, we learned that the rule is slightly different. There will be a day gain of 2 days of the week, provided when your date has crossed 28th of February. Thankfully for us, in this case, the day has crossed 28th of February, so we really don't have to worry about adding only 1 to the previous date. We will add 2 to Saturday. So when you're adding 2 days to Saturday, you're talking about Sunday and Monday. So 15th August 1988 would now be a Monday. Likewise, 15th August 1989 would now be Monday plus 1, so it should be a Tuesday. 15th August 1990 would now be Tuesday plus 1, it should ideally be a Wednesday. So we've arrived at 15th August 1990 being a Wednesday. From 15th August 1990, we'll have to count how many days we have till 23rd September 1990. Now, August will have 31 days of the month, out of which you remove 15 days of it, we are still left with 16 more days to go in the month of August. So out of these 16 days, what is the number of odd days that we will have? The number of odd days that you will have is nothing but the remainder of 16 over 7, which is nothing but 2. So you have 2 odd days in the month of August. Likewise, if you're looking at 23rd September, the number of odd days in 23rd September would be 23 over 7, which is nothing but 2 days. So effectively, we have a total of 4 odd days that we will have to count starting from Wednesday, 15th August 1990. So you count 4 days ahead starting from Wednesday. So you're looking at Thursday, Friday, Saturday and Sunday. So effectively, 23rd September 1990 will now be a Sunday. This is how we solve a question of this sort. Now let's see how we try solving this question in an alternative method. If you're a great fan of formulas, this is one formula that you can remember and use this formula to arrive at the day of a week. Now this formula is what is known as a Zelos formula. It looks something like this. Let's say the value that you're finding out is equal to d plus 13m minus 1 over 5. This is a step function. Here don't just look at this as square brackets. There's a definition of how this is defined. It's defined as the greatest integer less than or equal to x. So don't just look at it as brackets as such. Plus y plus again step function y upon 4 plus step function c upon 4 minus 2c. Now there are a few conventions that you have to keep in mind when you are using Zellers rule to arrive at the day of the week. Now in this formula, each of these variables denotes a particular unknown. D here represents the date that we are targeting. So here in this particular case, we are trying to find out what day of the week 23rd September will be. So the date is 23rd plus the M in the formula indicates the month. The month of our target month is September, but when you're using Zellers rule, your calendar starts from March, it doesn't start from January. You'll have to keep that in mind. So your first month as per the Zellers rule is March, second month is April, like that your 12th month is actually February. So using that particular calendar, September translates into the 7th month. So your second term now becomes 13 times 7 minus 1 over 5. You are finding the greatest integer less than or equal to this. Plus, Y indicates the last 2 digits of the year. The target year is 1990, the last 2 digits of 1990 is 90. So you say 90 plus, again the step function 90 over 4. Plus, C here indicates the first 2 digits of the century. So the first 2 digits of the century is 19. So you write this again as 19 over 4 step function minus 2 times of 19. You calculate what this value translates into. So what we have here is 23 plus 13 sevens are 91 minus 1 is 90 over 5 is 18. Greatest integer less than or equal to 18 is 18 plus 90 plus 90 over 4 will give us 88 would be divisible by 4. So here this would give us something like 22.5. The greatest integer less than or equal to 22.5 would now be 22. Plus this would give us 4.75. Greatest integer less than or equal to 4.75 would actually be 4. Minus 2 times of 19 is 38. So this translates into, this becomes 41, 131, 131 plus 4 is 135, 157. So 157 minus 38 gives us 119. So this gives us the number of days as such. So now we'll have to boil it down, we'll have to bring it down by dividing it by 7, or you're finding the number of odd days of 119 when you divide it by 7. Now, when you divide 119 over 7, your remainder is 0. When your remainder is 0, what do we do in such a case? We have a reference frame that says if you get 1 as the odd day, that translates into a Monday. If you get 2 as your odd day, that translates into a Tuesday. When you get 7, that translates into a Sunday. But what do we do when we get a remainder of 0? So here what we need to understand is this. 7 in this case does not really make any sense as such, because 7 when you divide by 7 will still give you an odd day of will give you no odd days at all. So here the 7 should be understood as the value 0. In other words, when you divide 119 by 7, you get a remainder of 0. So when you have 0 odd days, your day of the week must be a Sunday. So this very much tallies with what we have solved using the method earlier. Now what you need to keep in mind while using the Zellers rule is this. Point number 1, remember that your calendar month starts from March. Also keep in mind, if in any question your target month happens to be January or February, as per this calendar, if your target month happens to be the 11th month or the 12th month, then your target year is not just the last 2 digits of the year, but it is one subtracted from the last 2 digits of the year. Say for example, you're looking at 23rd February 1990. If you're looking at 23rd February 1990, my year here will not be 1990. It will not be 90 here. It will be 90 subtracted, 90 minus 1, it should be 89. So this is one thing that you have to keep in mind when you're using Zellers rule. Let's look at another model. Now let's look at another question that says, what day of the week was 23rd May 1942? Now this question is different from what we did earlier in the sense that there is really no reference point given to us that we can use as a base and then arrive at what day of the week 23rd May 1942 is, which means that in these kinds of cases, Zellers rule works best. So you try solving this using the Zellers rule and verify your answers with the method that I will describe now. So the year 1942, you can write it as the year 1600 plus 300 plus 41. Now when you talk about 41, remember that you're typically starting your count from 1901 to 1941. So year 1600 plus the year 300, that makes it 1900. Now you have 41 more years, so your count here is starting from 1901 to 1941. So this is one lot, and the next lot will now be from the 1st of January 1942 to 23rd May 1942. So what you have to now try identifying is the number of odd days in all these values as such. Now how many odd days would 1600 have? It is a leap year. The year 1600 is a leap year because it's divisible by 400. So this should, how many odd days should this have? 300 is a non-leap year, it's not divisible by 400. So how many odd days should 300 have? How many odd days should 41 have, and how many odd days should 1st of January to 23rd of May have? Once you're able to find out the number of odd days for all these numbers and you add them up, you will get a certain number that tells you that this is the total number of odd days in this period. Divided by 7, that will give you a remainder. Based on the remainder, you'll be able to easily find out what day of the week this translates into. Let's see how we look at finding out the number of odd days. Now 1600 years will have 0 odd days, 300 years will have 1 odd day, that being a non-leap year. 41 years will have how many leap years and how many non-leap years? 41 will have 10 leap years and remaining ones will be the non-leap years. So remaining ones will be 31 non-leap years. based on which you'll be able to find out how many odd days 41 years will have. And then to that you have to add the number of odd days from 1st Jan 1942 to 23rd May 1942. Let's see how we find out the number of odd days here. From 1st Jan till the end of Jan, the month of Jan is 31 days. So January 1942 will have 3 odd days, 31 divided by 7. February 1942 is definitely a non-leap year, so it will have 28 days, so it will not have any odd days or 0 odd days. If you're looking at March 1942, number of odd days in March 1942 will again be 3 because March has 31 days. Then April will have 30 days, it will have 2 odd days. Now you're looking at the date till 23rd May. So if you're talking about till 23rd May, till 21st of May you do not have any odd days, 23rd May will imply that you have 2 odd days. Now you add up all these number of odd days, that will give you a number. That number should be divisible by 7 and you find the remainder of it, you will get some value. That value will indicate, as per our table, where 1 is a Monday, 2 is a Tuesday, 3 is a Wednesday, this value will accordingly give you a particular day of the week. In this case, the day of the week for 23rd May 1942 will be Saturday. Complete this for yourself and verify your answer also using the Zellers Rule. Now let's take a look at a couple more different examples. This example reads that if the first day of an year is a Thursday, then how many Fridays are there in that year? Now the first day of the year happens to be a Thursday, we are being asked to find out how many Fridays are in that year. Now understand that what that year is has not been specified as such. So unless of course we really know what that particular year is, we will not be able to infer if it's a leap year or a non-leap year and how many days of the year it has and things like that. So which typically means that we will not be able to find out how many Fridays are in that year. So your answer should be cannot be determined. Now the question is slightly different. It says Raju booked a ticket to Hyderabad today, for which the day of journey is after 3 days from today. He scheduled his journey 12 days before the day of the journey. He received the money for the journey after 2 days from the day he scheduled the journey. If he received the money on Friday, what day of the week is today? Since he's asking us to find out what day of the week is today, let's assume that the day of the week today is some X. Now, he booked the ticket to Hyderabad today, which is X, for which the day of journey is after 3 days from today, which means the day of journey is X plus 3. So third day after X is your day of journey. He scheduled his journey 12 days before the journey, before the day of the journey. The day of the journey is X plus 3. He had actually planned for it 12 days prior. And he received the money for the journey after 2 days from the day he scheduled the journey. So X minus 9 is the day he scheduled the journey, and he received the money for that exactly 2 days after that, which means this is plus 2. So he says if this happens to be a Friday, what day of the week is today? Now this should not be difficult for us because now X value would simply be Friday plus 7. When we are saying Friday plus 7, 7 divided by 7 gives you no remainder, which means that today also must be a Friday. So this is how you actually solve these kinds of questions. So that brings us to a close of this session on
Hello friends, in this session we will discuss the rules of divisibility for the natural numbers. First things first, let's look at the rules of divisibility for 2. As we know, any number is divisible by 2 if its last digit is either 2, 4, 6, 8 or 0. Alternately, I can say that for any number, if the number formed by last one digit is divisible by 2, then the entire number is divisible by 2. Extending the idea, the divisibility rule for 4, if the number formed by the last 2 digits of a number is divisible by 4, then the entire number is divisible by 4. Divisibility rule for 8, if the number formed by the last 3 digits of a number is divisible by 8, then the entire number is divisible by 8. Divisibility rule for 16, last 4 digits, 32, last 5 digits, 64, last 5 digits, 6 digits, and so on and so forth. So in general, the divisibility rule for 2 to the power n would be so, if the number formed by the last n digits of a number is divisible by 2 to the power n, then the entire number is divisible by 2 to the power n. Same divisibility rule will also be true for 5 to the power n and 10 to the power n. So, for the divisibility rule for 5, if the number formed by the last one digit is divisible by 5, which means that the last digit is 5 or a 0, then the number is divisible by 5. For 25, if the last two digits are divisible by 25, so 25, 50, 75, 00. Divisibility rule for 125, last 3 digits. Divisibility rule for 625, last 4 digits, and so on and so forth. For 10 to the power n, it is pretty obvious. If the last digit is 0, the number is divisible by 10. If the last two digits are 0, the number is divisible by 100, and so on and so forth. So that's about the divisibility rules for 2 to the power n, 5 to the power n, and 10 to the power n. The rules of divisibility pertaining to 3 to the power n. If the sum of the digits of a number is divisible by 3, then the entire number is divisible by 3. Similarly, if the sum of the digits of a number is divisible by 9, then the entire number is also divisible by 9. Let us understand this divisibility rule for 9 a little more carefully. Let us say a number f. Now this number, if I write this number in the base 10 format, this number can be written as f plus 10 to the power 1 into d plus 10 square into c plus 10 cube into b plus 10 to the power 4 into a. Now if I am to divide this number by 9, let us say if I divide this number by 9, now 10 divided by 9, the remainder will be 1, 1 to the power 4 will also be 1, so effectively the remainder from here becomes 1 into a. So the remainder from here would be a. Similarly, this will be b, this will be c, this will be d, this will be e. Overall the remainder becomes a plus b plus c plus d plus e. So therefore the divisibility rule for 9, if the sum of the digits of a number is divisible by 9, then the entire number is also divisible by 9. Similarly, if I was to divide 10 by 3, the remainder would also have been 1. So therefore for 3 also the divisibility rule would have remained the same. This concept is very, very important. Let us say if I am looking at the divisibility rule for 11. For 11, what will happen is 10 divided by 11, the remainder will be minus 1. 10 is square minus 1 is square will become plus 1. This will be minus 1, this will be plus 1. So effectively I will have f minus d plus c minus b and a, which can be rewritten as a plus c plus e on one side minus b plus d on the other side, which gives us the divisibility rule for 11. We take the even digits on one side, we take the odd digits on the other side, we add them and we take their positive difference. If this positive difference is divisible by 11, the entire number is divisible by 11. So let's take an example. Let us say the number is 1 2 3 4 3 2 1 2 3. For this number, 1 plus 3 4 plus 3 7 plus 1 8 8 plus 3 11 on one side, and 2 plus 4 6 6 plus 2 8 8 plus 2 10 on the other side. 11 minus 10 is equal to 1. Because the difference is not divisible by 11, this number is not divisible by 11. And so on and so forth. So that is the divisibility rule for 11. Similarly, if I was to find the divisibility rule for 99, what I would have done is 19 for 99, because 99 is 100 minus 1, I would have written these numbers in the form of powers of 100. So by writing the number in the form of powers of 100 would mean that I'll pair them in 2's. Pairing them in 2's, if the 99 means that 100 minus 1, the remainder will be 1. So if the sum of these pairs of 2's is divisible by 99, then the entire number would also be divisible by 99. Similarly, for 101, the even pairs would be on one side, odd pairs would be on the other side. We take their positive difference. If this difference is divisible by 101, then the entire number would also be divisible by 101. Extending this idea further, we have a very interesting divisibility rule for 7, 11 and 13. We know that 7 into 11 into 13 is equal to 1001. Because 7 into 11 into 13 is 1001, that means that if 1000 is divided by 7, 11 or 13, the remainder would be minus 1. So on the basis of this, what we do is, let us say a number is 1, 2, 3, 4, 5, 3, 2, 1, 2, 3, 2, 3, 1. In order to divide this, check the divisibility of this number by 7, what I can do is, I'll pair the digits in 3's, 1, 2, 3, 4 and 1 will go separate. You add the even pairs on one side, you add the odd pairs on the other side. So first pair, third pair and 1, they will go on one side. The second and the fourth pair, they will go on the other side. If the difference of these sums is divisible by 7, then the entire number is divisible by 7. And similarly for 11 and similarly for 13. Which can be also written in a slightly different form. Let's say if I have to check the divisibility for 4, 3, 2, 1, 3, 5, 3. What we will do is, we take the last 3 digits out. Let us say the number becomes A and B. So now there are two numbers, A is equal to 4321 and B is equal to 353. If the difference of these two numbers A and B is divisible by 7, then the entire number is divisible by 7. Similarly, if this difference is divisible by 11, then the entire number is divisible by 11. Or if this difference is divisible by 13, then the entire number would also be divisible by 13. So that's the divisibility rule for 7, 11 and 13. Going back, we are done with the divisibility rule for 3 and 9. Now the so 1 done, 2 done, 3 done, 4, 5, 6. 6 is a composite number. Before I go to composite numbers, let me quickly close this divisibility rule for 7, 11 and 13. The divisibility rule for 7, there would be, let's say, two cases. Either the number is less than 3 digits, less than or up to 3 digits, or it is more than 3 digits. If the number is less than or up to 3 digits, then we simply divide the number by 7 and see what the remainder would be. If the remainder is 0, then the number is divisible by 7. On the other hand, if the number of digits is more than 3, we separate out the last 3 digits. The number, there are two numbers now, A and B. If this difference A minus B is divisible by 7, then the entire number is divisible by 7. Divisibility rule for 8 we have already seen, 9 we have seen, 10 we have seen, 11. For 11 there are two divisibility rules. Either I can use this even odd method, or I could do add the alternate digits on one side, other alternate digits on the other side. We take their positive difference. If this positive difference is divisible by 11, then the entire number is also divisible by 11. Divisibility rule for 13, again we have seen. Numbers greater than 13 we usually do not require to we usually do not need to know their divisibility rule. So at this moment we will not get into that. Now coming to composite numbers. Let us say if I am looking at the divisibility rule for 6. 6 is equal to 3 into 2. So if a number is divisible by 3, the number is divisible by 2, then the number would also be divisible by 6. 12 is equal to, it can be written as 6 into 2, 4 into 3. Can I say on the basis of this first statement that if a number is divisible by 2 and the number is divisible by 6, then the number would also be divisible by 12? No, that would not be true. Because if a number is divisible by 6, it will automatically be divisible by 2 also. So effectively this is this tantamounts to saying that if the number is divisible by 6, the number is divisible by 12 also, which is not right. On the other hand, if I say that the number is divisible by 3 and the number is divisible by 4, then the number is divisible by 12 also, that would be appropriate. What's the difference between these two cases? The difference is, when I look at 6 and 2, they are not co-prime. And because they are not co-prime, there is a common factor, as a result of which this divisibility rule will not be correct. So necessarily for composite numbers, the divisibility rule would be, if the number n can be written as a product of 2 or more than 2 co-primes, let us say a into b into c, then if the number is divisible by a, b and c, if the number is divisible by a, b and c, then the number would also be divisible by a into b into c. So if a number n can be written as a into b into c, where a, b and c are co-prime, then if the number is divisible by a comma b comma c, then the number is divisible by n also. Let's take an example. If the number 5668425y is divisible by 48, then what is the value of y? 48 is a composite number. 48 can be written as 12 into 4. It can also be written as 16 into 3. 16 and 3 would be composite, would be co-prime. So therefore 48 can be written as 16 into 3. So now I need to check the divisibility of this number by 16 and by 3. If the number is divisible by 16, that means that the number formed by the last 4 digits of the number should be divisible by 16. So 425y is divisible by 16. If 425y is divisible by 16, 16 to the 32, 10, 16 6 is 96, remainder is 9. That means that y is equal to 6, so that this becomes 96. If y is equal to 6, that is the only possibility from here. Checking for 3, 5 plus 6 is 11, 11 plus 6 is 17, 17 plus 12 is 29, plus 2 is 31, 31 plus 5 is 36, 36 plus 6 is 42, 42 is divisible by 3, so this number would also be divisible by 3, which means that overall number becomes divisible by 48. So that was a very simple example for the application of the rules of composite numbers to division. Hello friends, through this session we will look at the application of factors into numbers. Out of the 4 to 5 questions that you typically see from numbers in CAT or more or less any other exam, one of the questions will typically tend to be based on factors. A couple of important formulae, they have been mentioned here. We'll look at them one by one. First things first, we need to understand prime factor representation of a number. So let us say if n is equal to 120. The prime factor representation of 120, there are two ways of going about this. One is that I could write 120 is divisible by 2, so this becomes 60, divisible by 2 becomes 30, divisible by 2 becomes 15, 3 5s are 15. So from here I can say 120 is equal to 2 cube into 3 into 5. This is one long way of going about this. A slightly shorter version would have been, I directly observe from here that 120 is 12 into 10. If 120 is equal to 12 into 10, now 12 is 4 into 3, so this becomes 4 into 3, 10 is 5 into 2. 4 and 2, this will become 2 cube into 3 into 5, straightforward. This could have been done mentally, I don't really need to write this whole thing. And generally this is what you should do. So let us say I have to find the prime factor representation for 3600. For 3600, if I was to write this, that would be pretty long. So what I will do is 3600 is 36 into 100. 36 is 6 square, which becomes 2 square, 3 square. So that is one side gone. 100 is 5 into 2 whole square, 25 into 4. So that will become 5 multiplied by, so that's 25 into 4. So that becomes 5 into 2 whole square. 5 into 2 whole square is 5 square, 2 square. Overall this will become 3600. This becomes 2 to the power 4 into 3 square into 5 square. And so on and so forth. This would be a more suitable method for calculating the factors as compared to the normal long method. Wherever applicable, we should use this. So now that's about the prime factor representation. Number 2, if a number n can be represented as a to the power p into b to the power q into c to the power r, then the number of factors is p plus 1 into q plus 1 into r plus 1. The reason why it is very important for us to understand the rationale behind these formulae, so that we are able to manage any variation in the basic formula that may be applicable for a problem. If n is equal to a to the power p into b to the power q into c to the power r, let us say now I have to form a factor. In order to form a factor, I go to a to the power p. From a to the power p, I could pick a power a to the power 1, a square, a cube, 3, 4, 5, 6, 7, all the way till p. So for this I will get p ways of choosing. Also there is one possibility where I will not choose p, which means that a to the power 0, that will also give me one more way. So overall from a to the power p, the number of ways of choosing becomes p plus 1. Similarly from q, the number of ways 1, 2, 3, 4, 5, 6 all the way till q plus 1 on count of 0. So p plus 1 into q plus 1 and into r plus 1. So the number of factors is p plus 1 into q plus 1 into r plus 1. That's one. The second formula, the number of ways of expressing n as a product of two factors. If I am looking at the number of ways of expressing n as a product of two factors, what that means is, let us say for example I am looking at 120. 120 is equal to, again 12 into 10, 12 is 2 into 3, so this will become 2 into 3 into 3 into 5. Number of factors is equal to 3 plus 1, 4 into 2 into 2 is equal to 16. If I am to express 120 as a product of two factors, it can be written as 120 into 1, can be written as 60 into 2, can be written as 40 into 3, can be written as 24 into 5. Before that it can also be written as 30 into 4, can be written as 24 into 5, can be written as 20 into 6, can be written as 15 into 8, can be written as 12 into 10. So overall number of ways 1, 2, 3, 4, 5, 6, 7, 8, 8 to the 16 factors. So the number of ways of expressing 120 as a product of two factors is 16 upon 2, 8. Also, in order to understand this logically, the moment I choose one factor, the other factor is automatically chosen for me. So the moment I choose one factor, the other factor is already chosen for me. The number of ways of choosing a factor, that will be overall the same as the number of factors. However, because the same factor will appear on both the sides, once I am choosing 120, another time I will be choosing 1. The other factor is automatically chosen, so therefore the number of ways will become number of factors upon 2. So that's about the general formula. Number of ways of expressing n as a product of two factors is number of factors upon 2. In this, there will be an exception when the number is a perfect square. If a number is a perfect square, the number will be of the form a to the power 2p into b to the power 2q into c to the power 2r, where p, q and r are the they could be even, they could be odd. Now if I look at the number of factors for a perfect square, that will be 2p plus 1 into 2q plus 1 into 2r plus 1, which are all going to be odd numbers. If they are all going to be odd numbers, the product of odd numbers is odd, the number of factors is odd. If I do odd number upon 2, that will be decimal. Definitely the number of ways of writing of expressing a number as a 2 factors, it cannot be a decimal, there cannot be 3.5 ways of going about something. So it is either 3 or it is 4. The reason why we have this discrepancy is because let us say if I am looking at square of 36, the number of ways of expressing 36 as a product of 2 factors, 36 can be written as 6 into 6. So now whether I consider 6 into 6 or I don't consider 6 into 6, when I counted the number of factors, 6 was counted only once. So therefore if 6 into 6 can be considered, then I do a number of factors plus 1 upon 2. If 6 into 6 may not be considered, number of factors minus 1 upon 2. And that is where you get this these two formulae, plus 1 upon 2 in case the factors are not necessarily distinct. If the factors are necessarily distinct, then minus 1 upon 2. Finally, the formula for the sum of the factors is this is the formula for the sum of a GP, a to the power p plus 1 minus 1 upon a minus 1. Similarly, GP for b, b to the power q plus 1 minus 1 upon b minus 1, c to the power r plus 1 minus 1 upon c minus 1. So that gives us the sum of the factors. Some more formulae on the same. If n equals to a to the power p, b to the power q, c to the power r, formula 4, number of prime factors of n is count of a comma b comma c. The funda is that if I am looking at a prime factor of n, it will obviously be only a, b or c. The moment I combine 2 or more quantities, that will become a composite number. So it is very simply the count of a, b, c. So that's n. That's n, that is generally expressed as n. E, number of ways of writing n as a product of 2 coprimes. If I am looking at the number of ways of expressing n as a product of 2 coprimes, let us say I am choosing my first factor that will appear in this number of ways of writing n as a product of 2 coprimes. For the first factor, a to the power p, b to the power q, c to the power r, let us say I am looking at a to the power p. I cannot take a to the power p in parts. So let us say I am looking at 2 to the power 4. I will either take entire 2 to the power 4 or I will leave in the entire number. I cannot pick 2 to the power 1 and 2 to the power 3 on the other side, 2 square and 2 square on the other side, because the moment I break it, the two numbers, they will not remain coprime. So therefore either I will take a to the power p or I will not take a to the power p. Similarly, either take b to the power q or do not take b to the power q. Either take c to the power r or do not take c to the power r. For each of the terms, there are 2 ways of going about this. So therefore, the total number of ways becomes 2 to the power n. However, every time I pick up one side of the 2 factors, the other side is automatically chosen for me. So therefore 2 to the power n upon 2, so that's 2 to the power n minus 1. The number of ways of writing n as a product of 2 coprimes is 2 to the power n minus 1. The next one, number of coprimes to n that are less than n. What this means is, let's say if my number is 36, I am looking for the number of numbers from 1 to 36 that are coprime to 36. So we can write from here 1, 2 will be divisible by this, 2, 3, 4, 5, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15, 16, 17, 18, 19, so 17, 18, 19, 13 and 23, then 11 and 25, 7 and 29, 5 and 31, 1 and 35. So these are all the numbers that are coprime to 36. So the number of coprimes to 36, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. 12 numbers are there which do not have a common factor with 36. So those are coprimes to n. The general formula for this is n into 1 minus 1 by a into 1 minus 1 by b into 1 minus 1 by c. Lastly, the sum of the coprimes that are less than n, and that would be n by 2 into phi of n. As you can observe from here, if there are phi of n factors and phi of n numbers that are less than n and not divisible by 8, each pair will give me the same number 36. So 1 plus 35 is 36. 5 plus 31 is 36, 7 plus 29 is 36, 11 plus 25 is 36, 13, 23, 36, 17, 19 is also 36. So because each pair will give me the same sum, the number of pairs is n by 2, phi of n by 2, I'm sorry. So the number of pairs is phi of n by 2. Number of pairs multiplied by the sum of each pair gives me the overall sum. So n by 2 into phi of n is the sum of the coprimes. Example 1, let's say number n is equal to 2 to the power 9 into 3 to the power 7 into 7 to the power 8 into 10 square. What is the number of factors? A through G. So these are the 7 questions that we have in front of us. The first thing to, one very automatic instinct that comes to us is that if I'm looking at the number of factors, I have just remembered the formula. The number of factors is p plus 1 into q plus 1 into r plus 1. So I'll immediately 9 plus 1 into 7 plus 1 into 8 plus 1 into 2 plus 1, that will be my answer. That would be incorrect. That's incorrect because the number has to be first expressed in its prime factor format. Here if you observe, there is a 10. 10 is not a prime number. Because 10 is not a prime number, n is as of now not in its prime factor representation. So first things first, we need to express n in its prime factor representation. So n would be equal to 10 square is 5 square, 2 square. So this will become 2 to the power 11 into 3 to the power 7 into 5 square into 7 to the power 8. So this is my n. This n is not in its prime factor representation format. Now yes, I would be able to apply the formula. Number of factors will be 11 plus 1 into 7 plus 1 into 2 plus 1 into 8 plus 1. The second one, number of prime factors. The number of prime factors is the same as the count of these numbers here. So 2, 3, 5, 7. There are 4 numbers that I see here. So the number of prime factors will be 4. The number of even factors. What does it require for a factor to become even? For the factors to be even, what we will do is we will take a 2 out and then form factors from the remaining. Whatever factor you form, ultimately I will multiply it by 2. And if I multiply it by 2, it will become an even number. So therefore, if I take a 2 out, what I am left with is 2 to the power 10 into 3 to the power 7, 5 square, 7 to the power 8. So the number of factors will be 10 plus 1 into 7 plus 1 into 2 plus 1 into 8 plus 1. The number of odd factors, if a factor does not have a 2, then it will be odd. So I take out the 2, form factors from the remaining. So this will be 7 plus 1 into 2 plus 1 into 8 plus 1. The number of factors that are perfect squares. To form factors that are perfect squares, we individually make each of them perfect square, and then whatever factors we form from that. So I will write this as 2 square to the power 5 into 3 square whole cube into 5 square to the power 1 into 7 square to the power 4. Whatever odd portion remains from this, we will ignore that. Now whatever combination I take from this using this standard formula for p plus 1, q plus 1, r plus 1, that will be a perfect square. So the number of ways will be 5 plus 1 into 3 plus 1 into 1 plus 1 into 4 plus 1. So that's our answer. Next one, number of factors divisible by 12. For a factor to be divisible by 12, what do I require? The factor, the 12 is 12 into 4 into 3. So let me take a 2 square into 3 out, and I am left with 2 to the power 9 into 3 to the power 6 into 5 square into 7 to the power 8. Now whatever factor I form from here, that factor will ultimately be multiplied by 12. That way it will become a multiple of 12. So the number of factors which I can form from here, 9 plus 1 into 6 plus 1 into 2 plus 1 into 8 plus 1. That will be my answer. And lastly, number of factors divisible by 12 but not by 24. For a number to be divisible by 12, it should have 2 square into 3. For it to be not divisible by 24, it should not have any additional 2's coming from here, because 12 into 2, that will become 24. So that means that I'll write this number as 2 square into 3 into 3 to the power 6 into 5 square into 7 to the power 8 multiplied by 2 to the power 9. I'll definitely include this, definitely exclude this, and take factors from here. Put together these two, that will become a multiple of 12. Because there are no more 2's coming, it will not be a multiple of 24. So number of ways, 6 plus 1 into 2 plus 1 into 8 plus 1. So that's your answer. Example 2. How many 2-digit numbers have exactly 3 factors? If I'm looking at 3 factors, 3 factors means that the number has to be a perfect square, because like we discussed earlier, any composite number, it will have even number of factors, whereas any perfect square, it will have an odd number of factors. Also, if the number has 3 factors, 3 is 2 plus 1, so the number has to be of the form a square. If the number has to be of the form a square, that means that it should be the square of a prime number. Because if let us say if I'm looking at let's say 6 square, 6 square is 36, that would be equal to 2 square into 3 square. 2 square into 3 square will have 3 into 3, 9 factors. For it to have only 3 factors, it has to be of the form, let's say 5 square. Now 5 square will have only 2 plus 1, 3 factors. So therefore what you're looking for is squares of prime numbers that are 2-digit numbers. If I'm looking at the 2-digit numbers, the least possible number would have been 4 square equal to 16, and lastly 9 square is equal to 81. So between 4 and 9, how many prime numbers are there? The prime numbers between 4 and 9, 5 and 7. So 5 and 7, these are the two numbers which will be the squares of these two numbers. So 5 square and 7 square are 2-digit numbers that will have exactly 3 factors. Example 3, if n has exactly 7 factors, then how many factors will n square have? If n has exactly 7 factors, that means that n has to be of the form a to the power 6, because 7 is a prime number. 7 cannot be written as a product of 2 or more numbers. So necessarily n has to be of the form a to the power 6. So 6 plus 1, 7 factors will be there. Now if I'm looking at n square is equal to a to the power 12. If n square is a to the power 12, the number of factors for n is hello friends, in this session we will talk about percentage to fraction conversion. What happens is that more often than not, let's say when we are talking about DI, or we are looking at percentages as a topic, or the application of percentages to various other topics, on a lot of occasion the calculations, they become much easier if we are able to quickly convert percentages into fractions and vice versa. So let us say, for example, I have to calculate 14.28% of let's say 140. So in order to calculate 14.28% of 140, if I was to actually multiply 140 into 14.28, it will be very, very difficult. On the other hand, if I know that 14.28 is nothing but 1 upon 7, then immediately I can say 140 multiplied by 1 upon 7. So 1 upon 7 into 140 is 20. So 20 would be the value. So like this, the ability to convert percentages to fractions and vice versa comes very handy while solving problems throughout. So now what we'll do is we'll look at the basic fractions and then see what are the equivalent percentage values and vice versa. Naturally 1 upon 1 would be equal to 100%. So 1 upon 1 is 1 is 100%. 1 by 2 is equal to 50%. So in order to go from percentage to fraction, 50% is 50 upon 100. You divide the number on this side by 100 and you will get the LHS, and vice versa. So multiply the LHS by 100 and you will get the RHS. So 1 by 2 is equal to 50%. 1 upon 3 is equal to 33.33%. 0.33%. By extension, 2 upon 3 is equal to double of this, so that will be equal to 66.66%. 1 upon 4 is equal to 25%. 2 upon 4 is 1 by 2, that will be 50%. 3 upon 4 is equal to 25 into 3, 75%. 1 upon 5 is equal to 20%. 2 upon 5 is equal to 40%. 3 upon 5 is equal to 60%. 4 upon 5 is equal to 80%. 1 upon 6 is equal to 16.66%. Also, 1 upon 6 is half of 1 by 3. 1 by 3 is 33.33. 33.33 divided by 2 will be 16.66. So 1 upon 6 is 16.66%. 2 upon 6 is 1 by 3, so that will be 33.33. 3 upon 6 is 1 by 2, so that will be 50%. 4 upon 6 is 2 by 3, so that will be 66.66%. 5 upon 6 will be equal to 16.66 multiplied by 5. Now that will be very difficult to calculate. So what we will do is 5 upon 6 is also equal to 1 minus 1 upon 6. So 5 upon 6 is equal to 1 minus 1 upon 6. Now 1 is equal to 100. 1 upon 6 is 16.66. So 100 minus 16.66, this is 83.33%. So 5 upon 6 is 83.33%. 1 upon 7 is equal to 7 to the 14, 14 to the 28%. So 1 upon 7 is 7 to the 14, 14 to the 28%. 2 upon 7 is equal to 14 into 2, 28, 28 to the 56. So 28.56%. 3 upon 7 is equal to 14 to the 42, 42 to the 84. So 42.84%. 4 upon 7 is equal to 14 4 is 56, 56 to the 112. So from 112, only 12 will remain on the RHS. So 1 will come back. So this is equal to 56.112. This 1 will go to the go before the decimal. So this will be equal to 57.12%. 5 upon 7 is equal to 14 5 is 70, 70 to the 140. So once again 1 will come on this side. This will become 70 plus 1, 71.40. 6 upon 7 is equal to 14 6 is 84, 84 to the 168, 168. 1 will come on this side. So this will be equal to 85.68%. And obviously 7 upon 7 we know. So in each case what I am doing is 7 to the 14, 14 to the 28. From here I just keep multiplying this 14 by the respective number. So 14 to the 28, so 28.56. 14 3 is 42, 42.84. 14 4 is 56, 56.112. 112, 1 will go on this side. So this will become 57.12 and so on and so forth. So that's 1 by 7. 1 by 8 is equal to 1 by 8 should be half of 1 by 4. So 1 by 4 is 25%, half of 1 by 4 will be 12.5%. So 1 by 8 is equal to 12.5%. 2 upon 8 is 1 by 4, so that will be 25. 3 upon 8, 3 upon 8 is equal to 12 into 3. 12 3 is 36, 36, 5 into 3 is 15, 37.5. So this is equal to 37.5%. 4 upon 8 is 1 by 2, 5 upon 8. 5 upon 8 will be equal to 4 by 8 plus 1 by 8, let us say. 4 by 8 is 1 by 2, so 1 by 2 plus 1 by 8. 1 by 2 is 50%, 50 plus 12 upon 12.5 is equal to 62.5%. 6 upon 8 is 3 upon 4, so that will be 75. 7 upon 8 is equal to 100 minus 1 by 8. 100 minus 1 by 8, so 100 minus 12.5 is 87.5. So this is equivalent to 87.5%. Next one, 1 upon 9. 1 upon 9 and 1 upon 11, they have a very close relationship. 1 upon 9 is equal to 11.11 and 1 upon 11 is equal to 9.09. So 9 is 11, 11 is 9. If 1 upon 9 is known as given as 11.11, naturally for the further multiples of 1 upon 9, 2 upon 9 will be equal to 11 to the 22.22, 3 upon 9 is 33.33, 4 upon 9 is 44.44, 5 upon 9 is 55.55, and so on so forth. So 1 upon 9, the multiples should be pretty straightforward. On the other hand, if I was looking at multiples of 11, 1 upon 11 is 9.09, 2 upon 11 is equivalent to this into 2, 9 to the 18.18, 3 upon 11 is 9 to the 27.27, so on so forth. So 9 upon 11 will be 9 9 81.81, 10 upon 11 will be 90.90, 11 upon 11 will naturally be 1. So so on so forth. So from here 9 upon 11 is equal to 81.81, 10 upon 11 is equal to 90.90, and so on so forth. So that is about the multiples of 11. 1 by 10 is naturally 10, so 1 upon 10 should be pretty straightforward. 1 upon 10 is equal to 10, 2 upon 10 is equal to 20, and so on so forth. So these are the basic numbers, basic conversions, we must remember them. I think the multiplication part, that is pretty straightforward. We just remember the basic one, the first one, and the remaining ones can be multiplied from the first one. So now what we do is, let's spend a couple of minutes understanding how to remember these basic ones. From here 1 upon 1 is 100%, that's very simple, so we can remove this. 1 upon 5 is 20%, 1 upon 2 is 50%. So for for calculating the 50% of any number, you simply divide it by 2. So let us say I have to calculate 50% of 112. So in order to calculate 50% of 1 by 112, 50% is 1 by 2, so simply divide this by 2. So this is equal to 2 5 are 10, 2 6 are 12, so this is equal to 56. So remember, 50% is 1 by 2. Similarly, if I was to calculate 20% here, 20% is 1 upon 5. So for calculating 20% of this, I'll divide this by 5. Alternately, in this case, it would be easier. 112, 20%, this will be 224, so 22.4 would be the value. Moving on. So 1 by 2 is 50%, 50% is 1 by 2, 1 by 5 is 20%, and vice versa. So this should also be pretty straightforward. Next one, if I know that 1 is equal to 100%, 1 by 2 is equal to 50%. From here, if I divide this by 2, 1 upon 4 is equal to 25%. 1 upon 8 is equal to 25 upon 2, 12.5%. 1 upon 16 is equal to 12.5 upon 2. This will be equal to 6.25%. And so on so forth. So 1 upon 32 will be equal to 3.125%. How am I very quickly able to write these numbers? These are powers of 5. 5 to the power 0 is 1, 5 to the power 1 is 5, 5 square is 25, 25 5 ja 125, 125 5 ja 625, 625 5 ja 3125, and so on so forth. So that gives me 1, 1 by 2, 1 by 4, 1 by 8, 1 by 16, 1 by 32, and so on so forth. So that is about the multiples, the factors of 1 by 2. So this is also sorted. We know 1 by 4, we know 1 by 8. 1 by 10 is anyway simple, so there is nothing major about this. Next one, 1 by 3, 1 by 6, 1 by 9. This again should be pretty straightforward. As far as 1 by 9 and 1 by 11, these two are concerned, this as we discussed, 1 upon 9 is 11.11, 1 upon 11 is 9.09. So 9, 11, 11, 9. This to this, that should be straightforward. So 1 upon 9 is 11.11, 1 upon 11 is 9.09. So this conversion, this should also be pretty straightforward. For 1 by 3, we remember that 1 by 3 gives me all 3. So 1 by 3 is 33.33. 1 by 6 is half of that. So 1 by 6 is 16.66. Again, 1 by 6 has all the 6's here. So 1 by 3 has all the 3's here. 1 by 6 is takes 1, then followed by all 6's. So 1 by 6 is 16.66. 1 by 3 is 33.33. Last one, 1 upon 7. For 7, simply remember 7 into 2, 14. 14 2 ja 28. So 1 upon 7 is 14.28. So with this, we should be able to convert these numbers from 1 to 2, 2 to 3 very rapidly. Okay, let's take a couple of examples to understand this conversion better. Let's say we have to calculate 12.5% of 128, 37.5% of 232, 42.84% of 497. You should pause this video here for a couple of minutes, attempt these questions, and then you should continue from here. So 12.5% of 128. Now what is 12.5%? 12.5 is 1 upon 8. So 12.5 is 1 by 8. That means that this is same as 128 multiplied by 1 by 8. So 8 1s are 8, 4, 8 6 are 48. This is equal to 16. So 16 is your answer. Second one, 37.5%. 37.5 is 3 upon 8. So this will become 232 multiplied by 3 upon 8. Now what is 1 by 8? 8 2 is 16 and plus 7, 8 9 is 72. So 29 into 3, this is equal to 87. So 87 is your answer. Third one, 42.84. 42 2 is 84. So I remember that this has to be a multiple of 1 upon 7. 14 3 is 42. So this is 3 upon 7. This becomes 497 multiplied by 3 upon 7. 7 7 is 49, 7 1 is 7. So 71 into 3, this is equal to 213. So 213 is your answer. So that was about this percentage to fraction conversion. Hi, in this video we're going to talk about the basics of percentages. We're going to speak about percentage change. So let us say if A is equal to 100, B is equal to 150. Now B is what percentage more than A, or alternately A is what percentage less than B, and so on and so forth. Similarly, let us say if A is increased by 20%, then by what percentage should A be reduced to bring it back to its original value? So concepts like this, wherein we increase, decrease, things like that, that is what we're going to talk about. It's very interesting. It's a very basic concept in percentages, something that will be useful for you in the long term. So let's take up the first example. What we're going to do is we'll look at the example. You should attempt the question for a couple of minutes, and then you should continue with the video wherein we discuss the solution to the question. So here is your first question in front of you. The question is, marks scored by A is 50 and marks scored by B is 40. Then A is what percentage more than B? B is what percentage less than A is what percentage of B, and B is what percentage of A. So let's understand. A is equal to 50, B is equal to 40. If A is equal to 50, B is equal to 40, A is what percentage more than B? So A is what percentage more than B? Wherever we talk about more, this means we have to take the difference. So the difference here would be 50 minus 40. Than B, whatever comes after than, that will come in the denominator. So whatever comes after than, or whatever comes to after 2, that will appear in the denominator. So more than B. So more than B. So B is my base 40. Because we are speaking of percentage multiplied by 100. So 50 minus 40 is 10. 10 upon 40 multiplied by 100. 1 upon 4 is 25%. So this is equal to 25%. Second question, B is what percentage less than or more than A? If you are looking at B to A, now this time after than I have got a So B to A, the difference is still 10. So 50 minus 40 divided by, because after than we got A is equal to 50 upon 50 multiplied by 100, 1 upon 5, this is equal to 20%. Very interesting thing you observe here. When I look at as a percentage of B, the value is different. When I look at it as a percentage of A, the value is different. Because if the base changes for the same absolute difference, the percentage difference will be different. Third question, A is what percentage of B? So A is what percentage of B? This time there is no less or more, so therefore we can simply divide these. After off I have got a B, so B will appear in the denominator. A is equal to 50, B is equal to 40, so 50 upon 40 multiplied by 100. 50 upon 40 is 5 upon 4, 5 upon 4 is 1.25, so this is equal to 125%. And finally, B is what percentage of A? So B is what percentage of A? So this time A will be in the denominator, so A is in the denominator 50, B is in the numerator 40 multiplied by 100, 4 upon 5, 4 upon 5 is equal to 80%, so this will be 80%. And that was about this first example. Example 2. The ratio of A's salary to B's salary is 6:5. By what percentage does A earn more than B, and by what percentage does B earn less than A? So the ratio of the salaries is given as 6:5. So ratio is given as 6:5. So let us say A's income is 6K and B's income is 5K. Now the question is, A's income is what percentage more than B's income? So because once again there is more than B, there is a more, so I take the difference, 6 minus 5 upon 6K minus 5K divided by than B, so divided by 5K multiplied by 100, so this is 1 upon 5, this is equal to 20%. A's income is what percentage more than B? This is 20%. Second part, by what percentage is B's income less than A's income? B less than A. So B less than A, this time we'll have A in the denominator because there is a than, so we take the difference, so this will become 6K minus 5K divided by than A, so A is 6K multiplied by 100, this is equal to 1 upon 6, 1 upon 6 is 16.66%, so that will be your answer. Example 3. A is taller than B by 25%. By what percentage is B shorter than A? So A is taller than B by 25%. So if A is taller than B by 25%. If A is taller than B by 25%, if I was to take one of these two as the base over which we are looking at the increase or decrease, which one do you think should be the base? Very clearly, because I'm speaking of than B, so B should be the base. If I'm speaking of than B, B should be the base. Let us say B is equal to 100. If B is equal to 100, A is taller than B by 25%. This would mean that A is equal to 100 plus 25%, 125. And if A is equal to 125, then the question is, by what percentage is B less than A? So less than A will be in the denominator. So by what percentage this will be less? 125 minus 100 is the difference, divided by the base will be A, 125 multiplied by 100. So this is 25 upon 125, which is 1 upon 5. This is equal to 20%. So from here what you understand is, if B is more than A by 25%, then A will be less than B by 20% and vice versa. So A is taller than B by 25%, then B is shorter than A by 20%. Example 4. If A's salary is 10% less than B's salary, then by what percentage is B's salary greater than A's? If A's salary is 10% less than B's salary, that means that if I take B's salary as 100, then A's salary would be equal to 90, because A is less than B. by 10%. So if B salary is 100, A's salary will be 90. Now the question is, by what percentage is B's salary greater than A's salary? So greater than A, so from 90 we have to go to 100. So 100 from 90, the increase is of 10 on a base of 90. So multiplied by 100. 10 upon 90 is 1 upon 9. 1 upon 9 is 11.11%. So this is equal to 11.11%. Answer. Example 5. If the price of an item is increased by 25%, then by what percentage should it be brought down to bring it back to the original level? So the price of an item is increased by 25%. If the price of an item is increased by 25%, then by what percentage should it be brought down to bring it to the original level? So let us say originally the price was 100 rupees. From 100 it is increased by 25%. So from 100 it is increased to 125. Now from 125 to bring it back to 100, what should be the decrease? So 125 to 100, the increase is of 25 on a base of 125. So 25 upon 125 multiplied by 100. 25 upon 125 is 1 upon 5. 1 upon 5 is 20%. So this is equal to 20%. Consider the same question if it had been decreased by 25%. If it had been decreased by 25%, then by what percentage will you have to increase the price to bring it back to the original level? So let us say I start from 100, I decrease it by 25%, so this becomes 75. From 75, by what percentage should I increase it to bring it back to the original level? So 75 to 100, the increase is of 25. Divided by the current value, which is 75. So 25 upon 75 multiplied by 100. 25 upon 75 is 1 by 3. 1 by 3 is 33.33%. So this is equal to 33.33%. So in the first case we see it is increased by 25%. In order to bring it back, it will be 20%. If it is decreased by 25%, in order to bring it back, it will have to be increased by 33.33%. So that is about the increase or the decrease in the value. Example 6. If A's income is 16% more than B's income and B's income is 25% more than C's income, by what percentage is A's income more than C's income? So A is more than B by 16%, B is more than C by 25%. By what percentage is A more than C? So what we do is, let's say because we are speaking in terms of more than C, let's say C is equal to 100. B is more than C by 25%. If B is more than C by 25%, from here I increase it by 25, 125, this will be the value of B. Now A is 16% more than B. So 16% of 125, this will be equal to 20. So this is increased by 20, 125 increased by 20, this becomes 145. So this is the value of A, this was the value of C. Now the question is, by what percentage is A more than C? So from 100 to 125, 125 to 145, clearly 100 to 145, the increase is of 45%. So A will be 45% more than the value of C. This question could also have been handled using a different approach, wherein we talk about the successive percentage change. And successive percentage change is a very, very important concept in percentages, something that we're going to talk about next. Hi. In this video, we're going to talk about successive percentage change. It's a very, very important concept in percentages, something that will have very wide applications, and using the formula for successive change, we can solve the questions in a jiffy. So this is how it goes. Let us say the price of an item is first increased by 10%, then it is increased by 20%. What is the overall percentage increase in the price? So it is first increased by 10%, then it is increased by 20%. What is the overall percentage increase in the price? If it is first increased by 10%, so let us say initially it was 100. From 100 it is increased by 10%. So this will become 110. From 110, this is increased by 20%. If it is increased by 20%, 110, 20%, this is equal to 22. So 110 plus 22 is 132. So the final value will be 132. However, in case these values were a little more complicated, this calculation would have been very, very difficult for us. So what we do is we use a shortcut here. What we say is that if, let us say, it is first increased by X%, then it is increased by Y%, then the overall percentage increase will be X plus Y plus XY upon 100. So if the price of an item is first increased by X%, then it is increased by Y%, then the overall percentage increase will be X plus Y plus XY upon 100. So let's take this example. It is first increased by 10%, then it is increased by 20%. This will become 10 plus 20 plus 10 into 20 upon 100. This is equal to 10 plus 20 plus 2. This is equal to 32%, which is what we see here. Let's take another example. Let us say it was first increased by 20%, then it was increased by 30%, then the overall increase will be 20 plus 30 plus 20 into 30 upon 100. So this is equal to 2 3 is 6, 56%. It is not necessary that it has to be an increase only. This could have been a decrease also. In case it is a decrease, then instead of this plus 10, this would have become a minus 10. So let's take an example. Let us say it is minus 10%. The price is first decreased by 10%, and then it is increased by 20%. Then what will be the net percentage change? The net percentage change will be minus 10 plus 20. Minus into plus will be minus, so minus 10 into 20 upon 100. This is equal to 8%. So this will be 8% increase net. If both of them were negative, so let us say this is decreased by 10% followed by this is decreased by another 20%. What will be the effective percentage decrease? So this will be minus 10 minus 20, minus minus will be plus, so plus 10 into 20 upon 100. This is equal to minus 30 plus 2 minus 28%, and so on and so forth. So this is a formula for a successive change, and this formula will have very wide applications. What we're going to do now is we're going to take a couple of examples to understand this concept better. So example 1, the length of a rectangle is increased by 20% and its breadth is increased by 10%. What is the percentage change in the area? So the length of a rectangle is increased by 20%, the breadth is increased by 10%. What is the percentage change in the area? As we discussed earlier, you should pause the video, you should first attempt the question, and then you should continue again from the with the solution. So what we are saying is area is equal to length into breadth. If area is equal to length into breadth, the length is increased by 20% and the breadth is increased by 10%. What is the percentage change in area? Whenever we are looking at the product of two numbers, the formula for successive change can be applied there. So area is equal to length into breadth. The total let's say the total expenditure is equal to price per unit multiplied by the number of units, and so on and so forth. So from here what we will say is length is increased by 20%, breadth is increased by 20%. The net change will be 20 plus 10 plus 20 into 10 divided by 100. So this is equal to 32%. So the change in area will be 32%. Let's take another example. As we discussed, my expenditure is equal to cost per unit multiplied by number of units. Now let us say the price of sugar, it increases by 20%, and as a result of this 20% increase in the prices of price of sugar, a family reduces its consumption by 30%. If the family reduces its consumption by 30%, then what will be the impact on expenditure? So what will be the percentage change in expenditure? So the cost per unit has increased by 20%, the number of units has come down by 30%. What will be the percentage change in expenditure? Again the funda will be same, 20, because it is negative, so this will be minus 30, minus plus minus is minus, so minus 20 into 30 upon 100, this is equal to 20 minus 30 is minus 10, minus 10 minus 6 is minus 16, so this is equal to minus 16%. Let's take one more example. In the same situation, let us say I was to say that the cost of the sugar, has increased by 20%. By what percentage should the consumption be brought down so that my net expenditure it remains the same? So if the cost of sugar has increased by 20%, by what percentage should the consumption be brought down so that the net expenditure remains the same? So we can solve this question using both the methods, using two methods. We'll discuss both of them. Successive change method, the net percentage change is 0. This should be equal to 20 plus x plus 20 into x upon 100. So this will give me minus 20 is equal to 1 upon 5, 6 upon 5. So this is equal to 6 upon 5 into x. So x is equal to minus 100 upon 6%. So minus 100 upon 6, minus 100, 1 upon 6, 1 upon 6, 16.66. So this is equal to 16.66% reduction. Another method of looking at this question could have been, let us say initially I was at 100. If I increase the cost per unit from 100, I will have gone to 120. Now if I don't want my expenditure to change, then from this 120 I have to come back to 100. If I have to come back to 100, what will be the percentage change? So 100 to 120, 120 into 100, this is 120 to 100, the decrease is of 20 divided by on a base of 120. So 20 upon 120 multiplied by 100. 20 upon 120 is 1 upon 6, 1 upon 6 is 16.66%. So this has to be brought down by 16.66%. If we understand the concept, this method would be easier. However, in general, this method will be more foolproof. Let's take one more example on this. This time, what we do is, let us say the cost per unit has gone up by 30%. By what percentage should the number of units be brought down so that my expenditure increases by 10% only? So I want my net expenditure to increase by only 10%, whereas the cost has increased by 30%. By what percentage should I change my consumption? So using the formula, this will become 10 is equal to 30 plus x plus 30 into x upon 100. So this will give me minus 20 is equal to 1 plus 3 upon 10 is 13 upon 10 into x. So x is equal to minus 200 upon 13%. Another method of looking at the same question could have been, I would say initially, let us say I am at 100. From 100, if I increase the cost per unit by 30, I have gone to 130. However, because I want to increase my expenditure only by 10, so from 100 I want to go to 110. If I want to go to 110 from this value, so 130 to 110 is what I need to go. 130 to 110, this is a decrease of 20 on a base of 130 multiplied by 100. So 20 upon 130 multiplied by 100, 2 upon 30, this is equal to minus 200 upon 13%, which is what we arrived at using this method also. So that was some examples on successive change. Hello friends, in this section we'll talk about shortcut, a method. We'll talk about the application of the concept of successive percentage change to a specific question type in DI. The question is in front of you. The sales of a company increased in the following manner over the previous year from the year 2001 to the year 2005. So, year 2001, 2002, 3, 4, 5, the percentage increases 20%, 30%, 16%, 24%, and finally 35%. The question is, what is the overall percentage increase from the year 2000 to 2005? You should pause the video here, attempt this question, and then you can get back with the solution. So, what we have is year 01, 02, 03, 04 and 05. The percentage increase is given as 20%, 30%, 16%, 24% and finally 35%. One way of going about this question can be, let us say if I assume that the value of the price in year 2000 it was 100. So from this 100 to go to this 2005, what will happen is this will increase by 20%, so that will become 1.2, increases by 30%, so into 1.3, increases by 16%, so 1.16, increases by 24 to into 1.24, increases by 35 to into 1.35. This will give me the final value. However, this calculation will be very, very complicated. This will be very difficult for us. So instead of this, what we do is we use the formula for successive change. We'll need to use the formula iteratively. So first year it is increasing by 20, so this will become the net increase over here. This will be 20%. Second year it is 30%, so the net value will become 20 plus 30 plus 20 into 30 upon 100. So 2 3 is 6, this becomes 56%. So till this point this will become 56%. Next year it is increasing by 16%, so this will become 56 plus 16 plus 56 into 16 divided by 100. So from here we will have 56%, 56 and 16, so 56 plus 16 plus 56 into 16 upon 100. 56 plus 16 is 72, 72 plus 56 is slightly more than 50, 16 is slightly less than 20, 16 upon 2 is 8, this will become approximately 9, 62, 72, 72 plus 9 is 81, so this becomes 81. I'm not actually calculating it, I'm only approximating the value, so that will also do for me. 81 plus 24 plus 81 into 24 upon 100. 24 is approximately 1 upon 4. So 1 upon 4, 81 upon 4 will be 20. So this part will become 20. 81 plus 24 is 105. 105 plus 20 is 125. From 125, 125 plus 30 plus 125 into 35 upon 100. 125 is 5 upon 4. 5 upon 4 will be 4 9 is 36. 9 5s are 45. This will be approximately 45. It's slightly less than 45. Let's say 43. 125 plus 35 is 160. 160 plus 43 is 203. So 203% will be the percentage increase overall. In the process, I've also got the values for each of the years. Whatever calculation is required after this, that can be solved using this. This concept will be widely applicable in the case of pie charts also. So when we discuss pie charts, we'll look at specifically this kind of problems which can be.
Hello friends, we will begin with the RC section. This session is basically an intro to reading comprehension. I'll take you through the historical data as far as RCs and CAT goes. We'll look at the key elements that are required to solve the RCs, and also what are the major problems that students face when reading comprehension is concerned. To begin with, if you look at the word reading comprehension, there is a read and there is a comprehend. Is there a difference between reading and comprehension? What I basically want to say is, when I read a particular text, is it necessary that I also comprehend it? May not happen, isn't it? A lot of people can read a lot of things. How many of us actually comprehend what we learn? What is important? Is it only reading important, or is comprehending the text also equally important? Comprehending is also equally important. Rather, it is more important than just being able to read. To be more clear and simplistic, reading is a visual process. It is merely looking at those images, getting an idea about these images. These images have to be converted into meanings, have to be converted into some sense, which is what comprehension is. So comprehension is more of a cognitive process, is more about being able to understand. So what is being evaluated in reading comprehension? Given a data, can you understand that data? Now, how can someone evaluate whether you have understood the data or no? One way of that could be, I ask you to write a summary. I could ask you to write a précis. I could ask you to write a main idea. Or if I want to keep it a more of a multiple choice question type, I basically have to ask you questions. So what does CAT do in reading comprehension to be able to figure out, can you comprehend the data given to you, gives you a passage which is followed by a few questions, which is what the pattern of reading comprehension in CAT is. Now, to reiterate my point, can I read anything? Absolutely. For example, if you look at this passage or this paragraph given to you, would you be able to read it? I'm sure you can. If you can read English, you would be able to read this also, because this is also in the same script that the English language follows, which is basically the Roman script. So any person who can read the Roman script, would he be able to read French? Yes. German? Yes. But would he understand French? Might not be. Would he understand German? Might not be. So there is a clear-cut difference between reading and comprehension. A person who knows Spanish will be able to understand this, might not be able to will be able to understand this, but a person who does not know Spanish will not be able to understand. So reading and comprehension are two distinct processes. What CAT is evaluating is basically comprehension skills and not simply the reading skills. Now, to look at the weightage given to RC in CAT, let's go back to some data. Let's look at the last 2 years rather than looking at a lot of data, 2013 and 2014. 2013 CAT, there were two sections in CAT, section 1 and section 2. Section 1 was Quant and DI, section 2 was English and LR. I am assuming that you know that in 2013 CAT happened over a period of 20 to 22 days. Each day had 2 slots, and so in all there were 40 slots in the paper. Now each slot had a different paper pattern. Not just that, in the same slot itself people had a different paper pattern. Now though the paper pattern changed, the overall structure of the paper did not change, which means there were 30 questions in section 1, there were 30 questions in section 2. Now section 2 across the slots had 21 questions on English and had 9 questions on LR. Now of these 21 questions, around 9 to 10 questions were RC and the remaining questions were verbal ability and verbal reasoning. So if you look at it, 50% of the verbal section was RC in 2013, and that's the trend even in the previous years. Any year that you take, the verbal section in CAT has always been RC centric, which means 50% weightage in the verbal in CAT is given to RC. In fact, there was a time when CAT used to have 4 sections and RC used to be one entire section. Then they decided to merge the two and verbal RC came into one section, and then also the weightage given to RCs in CAT in the verbal section has always been 50%. You look at this year's CAT 2014 had 50 questions, out of which 34 in the second section were verbal and the rest were LR. Now out of these 34 questions, 16 questions were RC with 4 passages there, which again is a point. 50% weightage in CAT is given to the reading comprehension section. Now what is the point of giving you this data? 2 things. I'm trying to sell the importance of RCs in CAT. You cannot think of cracking the verbal section unless and until you are sure you can at least solve one passage. Second, among the various question types in CAT, RC probably is the only constant element. So I know come what happens, whatever be the paper pattern, whatever be the structure of the paper, RCs will always be an integral part of CAT. So therefore that particular reason, for other these 2 reasons, you will have to work on RCs. Am I saying you have to solve all the passages given to you? Absolutely not. I'm saying at least solve 1 or 2. Now of the passages given to you, how many passages you need to solve, how much time can you spend on these passages, etc., is what this slide will help you understand. But before we get into the slide on time allocation, some elements or some pointers which are very critical to solve RC. We call them the critical elements in reading comprehension. 1, speed reading. You have to be able to read the passage in a particular time. How much is this time? Totally depends upon what is the paper pattern that year, what is the time allocation, etc. We'll take CAT 14 as an example to prove how much time does a person get for reading comprehension. So one, speed reading, you should be able to read and comprehend the passage quickly. Second, you should be able to comprehend whatever data is given to you, because if you are not able to comprehend the passage, you will not be able to solve the questions following it. And third, you should be able to get the questions right. So three elements: one, read them quickly; second, being able to comprehend; and third would be questions. Now when someone is solving a passage, what are the elements that are important? He has to read and comprehend the passage and solve the questions following it. Now, which reading and comprehension will happen together? Questions is second process. Can I give equal time for both of them, or rather which will take more time? Would they take equal time, or one part takes more time than the other? Generally one will take more time than the other. In that case, where would I give more time? Should I give more time to reading, or should I give more time to the comprehension element? Generally people say reading takes more time, but if you look at it, when I'm solving my questions, I always will have to reread the passage also. It's a very rare case that one time reading helps me solve all the questions. So what happens is that while solving questions, the rereading time of a passage is also included in it. Therefore solving questions takes more time than the reading element. And if you notice, you go back to the history of CAT, look at the various paper patterns and the time allocation, you will come across an equation where generally the maximum time that you get to read and comprehend a passage in CAT does not go beyond 5 to 6 minutes. Now keeping this aim in mind, keeping this thing in mind, you have to start preparing for reading comprehension. Now when I am preparing for reading comprehension, what are the critical elements that come my way? There are three elements that are critical. One, as I said, speed reading. Second, we spoke about the comprehension element, and third, we spoke about the questions. Speed reading is connected to time allocation, and we'll take up speed reading once again when we look at questions to solve. Second element is comprehension. Now when we talk about problems in reading comprehension, these problems are generally problems with comprehending the passage. So what are the problems that people do come across when they comprehend the passage? One basic element: people don't read. Since you are not used to reading, it gets difficult for you to even comprehend or even sit down in one place and read data. That's one. Second, the subject not known to you. You are not aware of that subject. The subject acquaintance is not there, a reason why comprehension becomes a problem. And this is one of the major factors which makes passages difficult to read. That's one. Second, the style of the author. In short, the way the author has presented data. For example, if you look at two newspapers, let's take a newspaper like Times of India and a newspaper like the Hindu. Times of India is easier to read than the Hindu is because of the style of that. Times of India assumes that a person does not like reading, so it has to make the data very easily available to the reader. The Hindu assumes a person likes reading and gives a content intensive paper. Therefore, the two of them become easier or difficult to read is because the way the information has been present, which is basically the style element. And third element is the language element. Now in language, what is it that makes passages difficult to read? Most of the students give answers in terms of the words used. But if you notice, words is not so much of an issue, because most of the times you can guess the meaning of the word from the usage. But yes, words not known to you can reduce your speed. Would they impact your comprehension? May not be so much unless there is a question on it. But more than the words, the language structure, the way the sentences have been constructed, some of them are convoluted, twisted, have implied meanings. These make a passage difficult to comprehend than simply your words. Which essentially means the point that we are trying to make here is that these are the major factors which make passage reading difficult or passage comprehension difficult for a student. So if you work on these elements, if you work on these factors, to a large extent the comprehension element will happen. Now the sessions following this will now start focusing on each of them and what can be done to overcome these problems. Now the entire RC preparation is basically divided into two areas. One, efforts taken to improve your reading and comprehension, and second, efforts taken to solve the questions. What we are going to do is we'll focus more on the RNC at the initial stage, because unless this happens, the questions will not happen, and then we'll move on to the questions. Hello friends. In the intro to RC session, if you recollect, we discussed problems in comprehension. We said that in RCs, the problems are not so much with reading as much the problems are with the comprehension of a passage. If you recollect, we had said the various problems people encounter when they comprehend a problem. One is they do not read. Second, if you recollect, is a subject acquaintance. Third is the style of the author, and fourth would be the language element. This session focuses on the first point, that is reading. The inability of a person to be able to read, or the lack of reading skills that people have today. What are the problems that happen because of these, and what can be done to overcome these problems is what this session is going to be all about. To begin with, if I randomly ask you, how many of you actually like reading? Forget like reading, how many of you read? There was a time when we used to ask people, do you love reading? That love is gone. It's not even a like today. How many of people read? In our sessions, in workshops, many a times when we ask people, how many of you like reading, of a group of 300, 200 people, there are hardly 1 or 2 people who read. Then the question that comes to my mind is, when I'm talking about reading, is, do you think reading is important? Why is it that people don't read? Is that they feel that reading is not important, or there is some other reason for it? If I ask you, why do you think reading is important? Is it one, important? Do you think it is important? If it is not important, fair enough, then the discussion is not there. But if you think it is important, what are the reasons it is important? Now, if you predominantly look at it very carefully, why is reading important? It fundamentally helps your thought process. Generally, if you notice, people who read have a very different way of looking at things, have a different process. I'll just give you an example. I don't know how many of you probably have heard of something called scientific fiction. Scientific fiction is what certain authors like Dan Brown have tried in Angels and Demons, or there's an author called Julius Verne who probably tried, who was a scientific writer who spoke about aeroplanes when they were actually not invented. Scientific fiction basically requires whatever some scientific knowledge that is there, based on that a story is created. So the person who writes it imagines a lot. Now, China in 2011 conducted a sci-fi conference. It invited the scientific fiction writers across the world to their country. Now, this was the very first time that China did something in this direction. When one of them asked the Chinese delegates, one of these authors asked the Chinese delegates, why did China do something of this sort? And China gave an answer to that saying, we tried to figure out in the world, why are there only certain countries that are extremely good with research? Now, which are these countries who are extremely good with research? Let's take the United States for that matter, or for that matter Japan, for that matter Germany. Why is it that only certain countries are very good with it? And we figured out that because the children of these countries read. This is what reading does to you. For example, have you ever wondered why children are asked to read fairy tales? Elders are not asked to, because when a child starts reading fairy tales, he thinks of imagination, he thinks of certain things that can be done and possible. And unless a person imagines, unless the person is creative, new inventions can never happen. That is what reading does too. It alters your thought process completely. Second, reading fundamentally alters your language skills. It does something to you at a psychological level. For example, if you notice, people who are good speakers generally are good with the language. They are generally good with the language. And why are they good with the language? Because they read. Because they read, the language improvement happens and they become good speakers. Now, what is the scientific reason behind this? If you notice, reading is a psychological process. It is getting your mind acquainted to a lot of things. Now, since it's a psychological process and language speaking is also something to do with your mind and brain functions, they get interrelated. Okay, let me give you an example. If you notice, when we all think in a language. And this language is generally the language we are most comfortable with. And with most of us, it is our mother tongue. Okay, so now I think in my mother tongue and I speak in my mother tongue. My mind does not have to do any other process here. But now, if I think in my mother tongue and I speak in English, does my mind have to do some kind of a translation? Absolutely. So let's take an example. I want to say, the istriwala is at the door. The at the door I get immediately. Now, what does an istriwala called in English? I have a problem. I don't recollect. What does my mind do? It does a literal translation. Or the Iron Man is at the door. And the meaning totally changes. Right? Oh, then I realize, oh, I've made a mistake. I'm not supposed to say the Iron Man is at the door. But I don't know what an istriwala is called. So I'll end up saying the istriwala is at the door. And I've created something called as the Indian English, which is also called Hinglish. And in this whole bargain, have I lost a lot of time? Yes, fluency goes for a toss. But now, If I think in English and I speak in English, will I have the same problem? Not really. So when people say, no, I'll join an English speaking class, I'll join classes, I'll do grammar, I'll do vocabulary and my language skills will improve, it might not. Your language skills will improve in English only if your thinking language becomes English. And how can your thinking language become English? It's only when you read. So reading does that to you. One, it changes your thought process, and second, reading enables to improve your language skills. So even if you just read, RC will be taken care of, grammar will be taken care of, vocabulary will be taken care of. You wouldn't have to do any extra efforts only if you read. So if you possibly can read, the question would be, do I have an option of not reading? Not really. If you're looking at reading comprehension, you must have to start reading. The point now here is, what is it that I do? Read. Where should I start from if I have to start reading? Before you start reading, what you probably need to ask yourself is, for so many years of your life, why is it that you have never read? Are there any particular reasons? Because something that you haven't done for 20-21 years of your life, one session from my side or from our side is not going to change anything for you. You probably need to ask, have there been certain reasons why you haven't read? The slide shows you a few reasons that people give for not reading. One, I have a language phobia. Accepted. I'm not comfortable reading in English. Fine. Second, no one ever told me to read. My parents don't read, my friends never read, schools never told me, nothing of that's happened. So obviously I have not read. Third, it is very boring. Why? I have other interesting things to do in life. I have other hobbies. Fair enough. Then in that case also, this reason is acceptable. For a lot of people, they picked up the wrong book in life. Oh, I've heard so much about William Shakespeare. I wanted to start reading, so I picked up William Shakespeare's Comedy of Errors. Hey, and I opened the book, I have no idea what he was saying. So what happened in the whole bargain? I developed a phobia for reading. Now, where do you fall in? Are these one of your reasons for not reading? That's the first step. Can you find out reasons that you haven't really read in your life, and then can you start working towards reading? Now the question is, what is it that I read? What should I read? Your target is CAT. You have to start reading, which will help you solve the reading comprehension passages in CAT. But directly starting doing that will develop a phobia, because those passages are difficult, and if you don't read at all. So what is it that you can do to improve reading? Now to help you do that, we have categorized readers into 3 levels. Level 1, Level 2 and Level 3. Now Level 1 are readers or people who do not read at all. You have not even picked a single book in your life except your textbooks and your college books. You probably haven't even picked up comics to read in your life. That is my Level 1 reader. So if you are a Level 1 reader who absolutely has done no reading, starting directly with a non-fiction in CAT is not going to help you. In that case, can you start off with simpler writers? Which are these simpler writers? Certain Indian writers. Now some of them are extremely good with their language. The ones we would probably recommend could be books by Sudha Murthy, if you probably heard of her as a writer. There is a director and writer called Satyajit Ray. Satyajit Ray wrote a series of stories around the character Feluda. Felu is the name of the detective, Da means brother in Bengali. So Feluda is an Indian Sherlock Holmes. So if you try and read the stories written by Satyajit Ray around the character Feluda, there's crime, there's mystery, and the entire language will kind of get you interested in the entire process of reading. So if you can pick up Satyajit Ray's Feluda, you can pick up Sudha Murthy's any of her books. A lot of people have heard a lot about Chetan Bhagat. Is he a great author? Depends on how you look and you define a great author. Is he a popular one? Absolutely. So if Chetan Bhagat gets you to start reading, please go ahead and read it. We have no issues with it. But ideally, is he the best author to do it? Not really. More than Chetan Bhagat, maybe we could recommend an R.K. Narayan. You could pick up R.K. Narayan to read. If you want, at the match, you probably could pick up Ravindra Singh to read. So begin with certain Indian authors that you have heard, pick up the areas that you like reading, and then move on to Level 2. If you're comfortable with comics also, you can probably pick up the Amar Chitra Katha comics to read. The language in ACK or Amar Chitra Katha, at least till Uncle Pai was around, was impeccable. It's a flawless language, no grammatical errors, and has a lot of depth. You also had to think a lot to understand what ACK wrote all about. These are books, these are certain things that a person with Level 1 can start reading. Level 2 people are people who have done some reading, who probably have read a Chetan Bhagat, have read a Ravindra Singh, have probably even read a Sidney Sheldon. Some of these. Now for these kind of people, that is level 2, can you probably look at a slightly higher level of reading, which means can you start reading books which will now take you towards CAT. Now what kind of books will help you take towards CAT or understand CAT? For that probably you need to understand the kind of books that are there in the market. There are two kinds of book in the market. There is fiction, there is non-fiction. Now what is the main difference between fiction and non-fiction? A lot of students tell me fiction, ma'am, is something which is unreal, non-fiction is something that is real. Maybe yes, can be accepted, but if you probe a bit, if you notice a lot of fiction that is written against the backdrop of reality. If you notice these authors, especially people like Jeffrey Archer or Dan Brown, etc., do a lot of research before they actually write books, and therefore sometimes an author takes 2 to 3 years to write a book because the kind of research that they do. So just saying that fiction is something which is unreal and non-fiction is something that is real might not be a great classification. So how could you classify it? Hey, fiction is something that entertains you. Look at the movies you watch. Let's take for example a movie like A Wednesday and a movie like Gajni. Okay, a movie like A Wednesday had a story, but it also had a moral to give you. It also had some purpose behind the movie. While Gajni was simply meant for entertainment, it had no objective actually. So Gajni is fiction. Whenever a writer writes with the objective of entertaining you, it's fiction. But when the writer writes with an objective of giving you information, that essentially becomes non-fiction. What is it people generally prefer reading? Fiction. Because anything that is entertaining is easier to read as compared to what is information driven. You would read non-fiction only if you want information on it. If you don't want information on it, you will not really feel like. And today, since Wikipedia is there, Google is there, so many blogs, etc. are there, people generally use these kind of sources for non-fiction reading as compared to books essentially. Okay. Now, what are the kind of topics CAT gives us? Non-fiction. But can directly move on to non-fiction would be a problem if you're not interested in that topic. So what is the other alternative that you have is you combine certain books or choose certain books that combine fiction and non-fiction. We call certain books like these the semi-fiction. Now what do I mean by semi-fiction? The author gives you information as well as the author is entertaining you. Whenever any book is intended for information and entertainment, that book is called as a semi-fiction. So for people who are level 2 readers, meaning people who have read thrillers, etc., can move on to semi-fiction. Even the level 3 readers who have been doing intense reading, probably read books like B.G. Woodhouse, probably have read books like Tolkien's Lord of the Rings, etc., are also people who can move to the semi-fiction category. Now, how does semi-fiction help you? If you look at the kind of subject areas that CAT has evaluated in the last few years, you will find that certain subject areas reoccur in CAT. Now, which are these subject areas? It could be war, it could be politics. You probably, if you have a look at this table will help you understand that. These are the kind of subject areas that we've actually seen in CAT since 2001. And certain subject areas keep on repeating. So when we ask you to start reading on a particular subject area, we are asking you to pick up these subject areas and pick up semi-fiction to read on it. Now, how does semi-fiction help you? Let's take an example. Let's take up the subject war, history, geopolitics. Let's say you want to start reading on war, history, geopolitics to get acquainted with the subject element in CAT. How would you do that? One option is pick up a book on a non-fiction on these and start reading. But if that's not going to be what you want to do, you can pick up a semi-fiction. I'll give you an example of a semi-fiction in this case. There's an author called Ken Follett. Ken Follett has written a century trilogy. I'm assuming you know what a trilogy is. Tri means three. 3 books in a series is a trilogy. What Ken Follett has done is, he has used 3 main events in the 20th century, which basically were World War I, World War II and Cold War. His first book is Fall of the Giants. Fall of the Giants talks against the backdrop of World War I. So what he has done in this book is that he has created 5 hypothetical families. He talks of one family in the US, one in Germany, one in UK, other in France, the other in Russia. Now, through the stories of these 5 families, he narrates the events of World War I. Are the events narrated factual? Absolutely. Are the families? No. But the families and the stories there keep you entertained. So if you read fiction, Fall of the Giants, you get a fair idea on war, history and geopolitics. Take up the second book. Second book was based on World War II. So if you read the second book, you get a fair idea of how Hitler worked, how Roosevelt thought, how Churchill did the whole lot. So it helps you understand World War II with an entertainment element. And the last one is Cold War. It'll help you understand how politics between the two superpowers during Cold War actually shaped the way the world is today. Now what happens when you read something like these side of books? You're so engrossed in stories that you forget you're actually reading on these topics. So a passage given on these topics will become easier for you to read. Now why and how does this work? If you notice, reading is a psychological process. You can train your mind to accept any kind of information you give it, absolutely any kind of information. It is just about training your mind. Okay, let's take an example. Let's assume you are a student of computer science. Okay, you have been reading books on computer science. Your brain is accustomed to reading books on computer science. Suddenly, I give you a passage in philosophy. Let's say a passage by Quant, and I say, please read it. Your mind has no idea about philosophy. It doesn't even know what the whole thing means. Now you tell your mind, hey, read it, comprehend it, look at the questions, solve the questions, get the questions right, all this in 10 minutes. You think your mind, which has no idea about philosophy, will be able to do that? Absolutely not. What does your mind do? It reacts. And what's the reaction? It switches off. Come what happens, do what you do, your mind will stop comprehending the data given to you. Why? Because it is not acquainted with that topic. So when you start reading semi-fiction, you're so engrossed in the stories that you don't realize subconsciously you're acquainting your mind with these subject areas. So a passage given on any of these subject areas becomes easier for you to read and comprehend at the end of the day. Okay, let's take one more semi-fiction: philosophy, religion, mythology. Okay, there's a book called Sophie's World by Justin Gardner. It's a story of a girl called Sophie and how she learns more about the Western philosophers like Aristotle, Plato, Socrates in a very simple way. So essentially what happens when you're reading this book, you're reading about her and also getting acquainted to these areas, to these people. So subconsciously it is happening, so it becomes easier for you when you start reading a passage based on philosophy. Take up Dan Brown, Da Vinci Code. Against the backdrop of Christianity, it's mythology, it has architecture, it has history, it has religion. So when I'm reading the book Da Vinci, I'm so engrossed in the Holy Grail, in what Robert Langdon is doing, I actually forget that I'm reading on these topics. So a passage based on any of them starts getting easier for me to read. So what you possibly can do is pick up this area, the subject area list that I showed you some time back. And based on that, can you start choosing semi-fiction books to get acquainted with these subject areas? Trust me, it works wonderfully. If you don't want to do something of this sort, you probably can pick up the RC links uploaded on your homepage. These RC links are subject-wise, you start reading them, but then it is just non-fiction. So if you're not a person who can get yourself to read on subjects you dislike, that could turn out to be a little harmful because you will start developing a phobia for reading. But yes, if you are a person who can read anything, the RC links help wonderfully. But you are a person who has never read anything, does not like reading as a concept so much, rather than choosing the non-fiction, it would be better if you probably choose the semi-fiction books. So pick up the subject areas that we have mentioned and pick up the semi-fiction areas and start reading and getting acquainted with subject areas. Unless you start acquainting yourself with the subject areas, you will not be able to actually work on the comprehension element. So this is how you probably would work on the second element of RC, which is the
Hello students. So this is the first in a series of little capsule recordings which is intended to familiarize you with the area of critical reasoning. I mean, what is it that we look at as critical reasoning, why is it relevant and all that I will talk about. In the meantime, what is it? It's an area that demands your verbal skills as well as your reasoning skills, as is presented on the slide. The questions as regards the XAT, we might actually have questions in this area in two places. You might get standalone questions which we call critical reasoning questions, but you might also get similar questions, the critical reasoning type, in reading comprehension as well. Okay. Now through this little capsule we will go through understanding what it is that they actually are testing as a skill in this area before we get around to dealing with the question types later on. Okay. So, we said that critical reasoning demands your verbal skills, and we know what that is. I need to have skills with sentences, I need to understand and interpret properly, I need to be able to think about implications, everything that language gives me. So, you need to put in all your language skills, so I am not going to discuss those here, but I need to add to it logical thinking and I need to add to it reasoning. Now, what we really mean by logical thinking? We are actually talking about what we would normally call common sense, which is, if this is the case, then that must follow, is basically what logic is. You know, we put there what the dictionary definition is, and that is actually the truest or the closest meaning to logic. So, what will follow from something, and if we think in that line, if this is the case, if this is true, then that must follow, is what we call logic. Reasoning actually works both ways, or rather two ways. I can use logical thinking to take basis and move forward from that basis to arrive at something thereafter, or I can look at what someone has arrived at and try and understand what the basis was for that. Okay. So, reasoning is the whole business of use of reason to be able to arrive at something that you understand. So, I can use it both ways, either to arrive at understanding or recognize how it was arrived at. Okay. Now, in reasoning we have two little, I mean there's a lot to talk about, but something that is relevant to our understanding. There are two ways that we look at reasoning. One is what we call deductive reasoning and one is inductive reasoning. Now, deductive reasoning is a term that you've heard. It really means that we move forward only from what we have. That means we do not add anything to it. If you give me A and B, then I will only connect A and B and I will see what I can derive from that. That means I don't bring anything else in. Now, that would be deductive reasoning. So, deduction is going forward from what you have as basis. Inductive reasoning, on the other hand, would mean you give me A and B and I think, no, this is not adequate, but there is something else I know that is connected to this, so I'll bring that in. So, I bring C in on my own and then I arrive at some understanding from that. In other words, inductive reasoning takes into account things that people believe are relevant. Deductive reasoning uses only what it is that that you have as basis, but inductive reasoning we might actually add something that we believe is relevant and helps us arrive at a clear understanding, right. So, that is your difference between deductive and inductive. Now, in this business of reasoning, there are two basic concepts, I mean apart from our verbal skills and our thinking skills and all that. Practice with two concepts, and we might have, you will come across them now and then, actually help you in this reasoning thing. One is this business of syllogisms, and let's not forget what syllogisms are. Take statements which are, if true, will lead to something that will follow. That is basically what we call syllogisms. So, your if then sequence of statements or conditions and effect of those conditions statements, these are what we call syllogisms also, and therefore you recall what you know about that, look it up a little bit. And the other thing is what we call Venn diagrams. Now, Venn diagrams, you're familiar with them, I don't need to go over them, but basically Venn diagrams help you understand clearly how qualifications or sub qualifications can be used logically. Okay. So, keep in mind that even when I'm looking at things in content or in text, if I can look at qualifications or sub categorization or sub qualifications in the form of Venn diagrams, I can actually get a better sense of the kind of possibilities that I'm dealing with. Okay. So, that is basically what one needs to keep in mind when you handle critical reasoning. So, is there a concept involved? Yes, there is a concept involved, but before we get down to that concept, let's ask ourselves, if all of us use reasoning, because logic and reasoning is common to all of us, we said it is common sense. If all of us use reasoning, then why is it that we sometimes disagree on the same issue? Why do we have different arguments on the same issue? The possibilities are because, when you give me some basis, I might look only at some of the things I have been given and not at all, whereas you might look at all things given and therefore you arrive at a different understanding and I arrive at something else, and therefore we disagree. Or sometimes we don't take into account all the circumstances or possibilities, or I take into account some circumstances and you don't, and therefore we might disagree. That means we arrive at end results which are different, isn't it? Or sometimes we take things for granted. I take for granted that this is going to apply, whereas you don't take it for granted, I need to tell you, and therefore sometimes you don't understand the way I arrive at my end result, and therefore we disagree. Or sometimes we use induction, that means we use prior elements, and those prior elements sometimes are not things that other people share. They might be prior understanding, they might be prior belief, they might even be elements of information that other people do not have, and then in that case I know what I am using, but you don't know what I have used, and therefore you disagree. So, if you look at that list there, this only gets you to what is it that we actually disagree over, why do we disagree over it, when actually we are using the same method, all of us. We are using a logical method, we are using reasoning, which is actually common sense, but disagreements, now you realize why they happen, because we actually take into account, don't take into account, take for granted different things. Alright. Now, we have used the word argument here. So now let's proceed to discuss what is this thing that we call an argument. What is an argument? So when we put together an argument in our heads, what are we really doing? We use information, all right? We use fact, we use basis, we use some, let us say something that we might actually have understood earlier on also, and we use those and we put them together as basis for some particular thing that we derive, right? So I might use a piece of fact, I might use two pieces of fact, and therefore putting them together I arrive at something from that, all right? For instance, if look at it very simply, if you say that there is heavy cloud today and the air temperature has dropped, then putting those two things which are facts together, I would derive a logical, let's say, understanding that knowing what I know about clouds, I know that heavy cloud would mean big condensation and possible precipitation. I know that lowering of temperature means that the condensation is going to happen faster. Therefore, keeping all these things in mind, which are all factual, I put these basis elements together and arrive at a conclusion that it's going to rain. But I might sometimes use prior understanding as well, isn't it? For instance, there's heavy cloud and the wind is blowing, in this direction, but on previous days, or at least because of the nature of the geographical nature of this area, the wind most often stops, the clouds stop when they reach here, and therefore I have an understanding that in most cases the clouds don't go beyond the hills over here, and therefore it's likely to rain here. But you recognize in that case I'm using prior understanding. So we use in our heads, we use information, sometimes prior understanding, we put all this together as basis, we put those basis elements together, there's some commonality that they actually have in hand in amongst themselves, and then we arrive at something that we understand, which is what we would call an end understanding. So when I think of all this, that is what I put my understanding together as. But when I present it to you, when I present it to somebody, when I speak it or when I write it, then I'm presenting an argument. So let's not forget that all the thinking that we do in our heads is not really an argument. We work things out for ourselves. We deliver it as an argument when we actually explain it to somebody else. Okay, so that's what an argument is, and that's the basic concept that goes into critical reasoning. So we will examine that in some more detail. So let's take two very small examples of an argument, right? Now we've got them on the board there, on the slide there. One we are saying is that Ram Gopal Verma is making a new film with Amitabh Bachchan as a protagonist. Now you recognize that that is very clearly a basis statement because it's a piece of information. I am giving you an information about who is making a new film with whom as the protagonist. And then I say this is sure to be a hit. Now when I say this is sure to be a hit, that is not a piece of information. That is an opinion that I have. But how did I arrive at it? Going by the piece of information that I have and recognizing what it is that that piece of information causes me to think of, I come down to a conclusion that this is sure to be a hit. Now as long as I think this in my head, I haven't presented an argument yet, but the moment I speak it or write it and give it to somebody or present it to someone, then I presented an argument, right? Let's look at the second one there. It's cloudy today, right? Now if it's cloudy today, and so I will purchase an umbrella. So I've got a similar progression. It's cloudy today and I will purchase an umbrella would mean because it's cloudy today, recognizing that I've decided to purchase an umbrella. Now let's look at these two things. Let's take the first one. Now if all I've got is that Ram Gopal Verma is making a new film with AB as protagonist, if that's all I have, how did I arrive at the fact that it's sure to be a hit? Obviously I've kept in mind the previous experience I've seen or the previous observations I've had of the combination of these two people in films, and keeping that in mind, that means I not only take this statement but I induce something, I induce prior experience and I come down to a conclusion, right? Look at the rain one. If we say it's cloudy today, then when we say it's cloudy today and then you say so I will purchase an umbrella, you're saying it's cloudy today. When there are clouds it normally rains, therefore today it's likely to rain and then I will purchase an umbrella. So you recognize that we don't always, when we present arguments, we don't always present everything that we've used. In our heads we've used a lot of things, but we tend to give people only what we think they need, and we might withhold or might not bother to present what we think people will commonly understand. So that's usually what happens in an argument. Nobody presents their arguments in every bit of detail that goes into it. They tend to present what they think people need, and they keep back or don't worry about things that they believe people already have. But nevertheless, they use all of that to move on to a conclusion that they derive. Alright, so these two examples help you realize how people present arguments. So if this is how we present arguments, then you recognize there must be components to an argument. That means the parts to an argument. What would they be? So we have this word that we call premises. Now essentially what are premises? Premises are basis elements, right? So evidence or fact that we use to present or to support some understanding that we derive, we would call these premises, right? So premises are, almost all of us think that premises are always fact based premises. Broadly yes, but sometimes you recognize I might use as a premise something that is not exactly fact based, but might be some prior understanding and I state that understanding, or might be some prior belief and I state that belief. So basically what we are saying is premises are basis statements which are actually presented. Let's not forget, if I don't present them to you, then they aren't premises. What I present as my basis elements are premises. And therefore the argument is based on those premises. And what does the argument finally amount to? It amounts to a conclusion. So what is it that the argument finally ends up saying? Using these premises, what is it that the person actually arrives at, and what's the person trying to prove? That particular understanding that the person wants to deliver, the main idea for which that particular argument itself is constructed, is actually, at least according to the author who makes that, a logical certainty. Given these premises, that is going to be the end result. Then that is what we call a conclusion. Let's not forget that a conclusion is what the premises are used for. The premises add together and help a person arrive at a conclusion. Alright. So these are your two basic elements, the things that are stated. The premises are the basis elements given. The conclusion is what someone arrives at from that basis. But there are a few other elements. Let's move on and see what that is. So as I just told you, the premises are the things that we state. But as we recognize from the examples that we looked at in the earlier slide, I might state some things, but very obviously along with what I've stated, I've used certain other elements as well to arrive at my conclusion. So those are also basis then. The statements that, I mean the elements that I used but I didn't state are also part of my basis. It's just that I didn't state them. And therefore we have a term for those. We call them assumptions. If I'm making the argument, then the bits that I don't state are my assumptions. I assume that I don't need to state these things because the persons to whom I'm making this argument, they already know. Therefore, the unstated basis elements that the author simply assumes to be true. He says that these are true and I don't think I need to tell people about this. So then you find that people tend to somehow not state certain things. But that is not because they don't believe that they want to hide it. It's just that they believe there's no need to state it. It's fairly obvious, or people know, or they should be able to figure out for themselves. But you recognize that assumptions are also basis elements. So if assumptions, crucial assumptions for instance are things that actually add to the argument, and minus the assumptions, the argument may not stand. If it's some marginal assumption, okay, but a major assumption if I don't give you, you recognize that if you say that particular statement is not to be considered, then the argument itself may not stand, right? So now you know what assumptions are. Okay. But we talked about conclusions earlier. We said conclusions are what it is that the argument is intended to deliver. But there's another word you must be familiar with, or you should familiarize yourself with, which is what we call inferences. Inferences are not the main understanding that the argument has. They are actually the spin-offs or the tangential or peripheral parts, right? So they are not the main understanding, but they are these incidental bits. In other words, a conclusion would use all the premises, put it together, recognize what they are doing together, and come down to a main conclusion. An inference would mean any one of the premises or more can actually draw me to certain other understanding as well. So tangential bits of understanding that we can arrive at from the same premises, when we actually are putting together an argument, we can deliver certain other little bits of understanding which are not the focus of the argument. We would call these inferences. So these then are your components. You have premises, which are basis elements. You have conclusions, which are the end result of the argument. You have assumptions, which are also basis elements except that they haven't been stated. And you might have inferences, which is things that you can understand apart from the conclusion that is actually provided. Okay. So now that we know the components, let's look at how it is that we need to deal with them. So let's take a sample. Now that we've understood something about those components, let's take a sample and see whether we can work that out, right? Now we've got there, you've got the three statements there about J.K. Rowling and her 7th Harry Potter book, and it's certain to be a bestseller. Very clearly you recognize that the first two statements are on the slide are actually pieces of information, right? The third statement, however, is a conclusion because one is making a prediction about what might happen. And then we are asking what would you need to add to complete the logic of this argument? That means to give it a proper line of reasoning. Now what is my connection? Obviously my connection is this author and her book and the kind of hero that we have. But if we are saying it's certain to be a bestseller, then very obviously we mean that the fact that this author has written this book and it has the same kind of hero who we've seen earlier is going to be a bestseller. In other words, we recognize that we must also have used our experience of what the previous Harry Potter books were like in terms of their success. So if I know that the previous Harry Potter books were also great successes, that would prompt me to say that the 7th one will also be a success. So you recognize that is the something that completes the logic or the line of reasoning of my argument. Now I might not have stated it, but for anyone who thinks, you realize that I must have used that, otherwise I would not have been able to make the statement that it's a bestseller. So that is what we call an assumption, and therefore you recognize what this question asks there is what is the assumption that this person has used. And the assumption, very obviously, you've looked at all the choices there, but now that we've discussed it, you realize that there is only one choice there that works, which is the Harry Potter stories, right? Now if we say have gripped the imagination of readers the world over, that doesn't tell you exactly that they've been hits. But if I say her 6 earlier books in this series have all been bestsellers, then you recognize this author, that hero in the series, right? So the same series, this author, that hero have always turned out, that combination has always been a hit in every book that has come so far. Therefore the 7th book will also be a bestseller. So your third statement there, the third choice there, ends up being your assumption. So now you recognize what we mean by composition of an argument and what these things that we call assumptions are. Okay, now let's move on. So this slide, I don't need to explain it, but you can just have a look at it because we just talked about it before this in terms of what is it about choice C that makes it relevant, right? So one thing that you must understand here is that this choice 3, which is her 6 earlier books in the series, is the assumption. But you also recognize then that minus that statement, we could not have made that conclusion. In fact, except for the fact that there has been this past experience, how could we make this conclusion that it will be a bestseller? It wouldn't be logically justified, right? So see, there's another thing therefore that you must keep in mind. The assumptions, we might call these unstated elements of basis assumptions, but just because they are unstated doesn't necessarily mean they are not valuable. Assumptions can be as valuable and necessary to the argument as premises themselves are. Sometimes we might have minor assumptions, not really all that relevant, but sometimes we leave major things out because we believe people know. So assumptions are just like premises, except that the premises are stated, the assumptions are not, but they both have an equal role to play in the making of an argument. Okay, so now that we are clear with that, we can progress to evaluate what we have to deal with. So if we are to sum this up, okay, we've got a little equation, a little formula kind of thing there. If you are to sum this up, you recognize that premises, which is stated information, is often added to by at least unstated stuff, assumptions. So premises and assumptions. So we might sometimes leave assumptions unstated, sometimes leave information unstated, which will be assumptions. So premises plus whatever assumptions a person might have lead to a conclusion by way of understanding, right? Now understanding is typically a logical end result, but then most of us don't just stop with understanding. We go ahead and apply that understanding, right? We say, okay, now that I've understood this, I can use it, I can take a decision, I can come up with a plan, and therefore there are circumstances that we must apply that to. So that understanding then gets applied in certain circumstances. So I take into account more statements that I need to consider or more assumptions that I need to consider, which are more in the nature of circumstances, and then I arrive at a plan kind of conclusion. So let's remember that assumptions can actually be between premises and basic understanding and the understanding part of the argument, but assumptions can also be between the understanding part of the argument and a plan. So when we say conclusion, we might mean a conclusion which is merely the theoretical end if the argument hasn't gone further, but we might mean the extension of the conclusion to a application in the form of a decision or a plan if the argument goes as far as that. And if it goes to that stage, then let's remember that assumptions can be logically required in terms of between the premises and the understanding. They might also be circumstance requirements between the understanding and its application. So this little formula that we have on the slide here more or less places in your mind clearly what it is that an argument is and what its components are. And this you must always keep in mind when you're tackling the kind of questions that critical reasoning throws up, whether in critical reasoning or in reading comprehension, right? This little layout is essential. Now let's move. So we just summed it up, but let's be absolutely clear. Premises are those statements that provide the information or the basis. Conclusion are the statements that require the support of that information or basis. And you must remember that what people are testing, when they ask you these questions, whether in comprehension or in CR, is they're asking whether you've recognized the components and you've recognized the line of reasoning. That means how these components have worked together to form the argument. Okay, so this in substance, in summary, is what it is that people expect of you in critical reasoning and what it is they expect of you when they ask you reasoning questions in RC. Okay, we'll look at a few samples and figure that out. So to close this capsule, let's look at some little samples and identify these bits in the samples, right? Now you've got these statements there, so you can look at this. When we say the hourly wage of fresh college graduates is about $12 less than that of regular workers, you recognize that's clearly a piece of information. So that's a premise. Hence, shopkeepers feel that's economical to hire fresh college graduates to conduct these stocks audits in their stores. I know that stock audits need to be conducted, so that's a premise as well, maybe. I mean, you recognize that's a piece of information, but there is a conclusion here. The conclusion is that shopkeepers feel, so hence shopkeepers have concluded that it's economical to hire fresh college graduates. Why is that? Now, I've got a premise here. I've got fresh college graduates, you pay them $12 less per hour in comparison to wages, and you can then use and then therefore get fresh college graduates to do your stock audit. But the fact is, there must be an assumption here. How can you get a fresh college graduate to do your stock audit? Only if you assume that a fresh college graduate is able to do stock audit. So that would be the assumption, correct? So your premise is the business of the wage. Your conclusion is, let's do this with fresh college graduates, but the assumption is college graduates are able to do this. It's not stated, but obviously this person is keeping that in mind. Otherwise, they couldn't have concluded that. Let's look at the second one. In a survey, the dining habits of about 100 adults were observed. It was found that those who took alcohol just before lunch consumed less calories at lunch than those who did not take alcohol. This is definitely information because it was observed through a survey, right? This indicates, so the person is taking this and moving forward to some understanding. This indicates that those who want to reduce their calorie intake should consume some alcohol before lunch. This indicates that those who want to reduce their calorie intake should consume some alcohol before lunch. There is clearly a conclusion there. Now, is there an assumption here? What is the assumption? The dining habits of 100 adults were observed. It was found that those who took alcohol just before lunch consumed less calories at lunch. Now, the point is, the assumption here is, it is the, let us say, people might have had less calories simply because they were not interested in eating. Now, if you are saying that this applies, so the assumption here would only be that every time people actually have alcohol, they would actually get calories and they would not want to eat. So only if you are saying every time people imbibe alcohol, they don't want to eat, then you can say that people who want to reduce their calorie intake should consume alcohol before lunch. So there are various assumptions involved. One is about calorie content itself, but the very obvious assumption here is that every time people imbibe alcohol, they wouldn't want to eat, right? So that is something that finishes this argument as an assumption. Now, what about the third one? Baldness will soon be a thing of the past. Now, that's clearly a conclusion. That's clearly an opinion. Baldness will soon be a thing of the past. Someone is making a prediction there. The patent of finasteride, the drug that cures baldness in men, expires next month. That's a piece of information, right? That's a premise. More companies can then manufacture the drug, but this is understanding, isn't it? You're saying if the patent expires, then more companies can manufacture the drug. So that is a intermediate piece of understanding. Intermediate understanding me used as basis. And the price will come down to be within the reach of all those who are bald. Again, that's also intermediate understanding. Someone is saying that the patent expires. When the patent expires, more people will be able to manufacture the drug, but that's clearly somebody's understanding. And the price will come down as a result of that manufacture. That's also some understanding. Now, the person has used the premises, has used the intermediate understanding and said, and therefore baldness will actually disappear. So you recognize here that we have in this particular sample, we have one fact-based premise and we have two other statements which are what we will call intermediate understanding. Please keep that in mind because in subsequent capsules we will be discussing that. Intermediate understanding is something that is not exactly fact, but a person is using it as basis for an ultimate conclusion that they want to arrive at. Okay, so those then are your identifications here, and with that this particular capsule is done. Keep all of these in mind because we will, from your subsequent capsules, we will get around to tackling how we can use these to tackle questions.